Were we the first? A journey through deep time. Welcome to Simply About Earth. Before we dive into tonight's journey, let me know in the comments where you're watching from. I love connecting with viewers from around the globe as we explore the mysteries of our planet together. Tonight, I want to take you somewhere quiet, somewhere beneath the noise of our cities and far below the thin layer of time we call history. Down there in the deep silence of the Earth itself, there are stories that we may never hear, and yet sometimes you cannot help but wonder if those stories might still be there waiting for us, hidden in the stone and soil beneath our feet. What if we are not the first? It's a question that at first almost feels like a riddle, one of those thoughts that you can brush aside with a laugh. After all, we know our history, don't we? We can trace it from the first carved stones to the pyramids, from the printing press to rockets and satellites. We can see the line clearly, but then you remember something. That line is thin, fragile. It stretches back only a few thousand years, and then it stops, disappearing into the fog of prehistory. Before that, there are only bones, scattered tools, and the faintest traces of fire left by the humans who came before us. And if you step back even farther, outside of the comfort of human history, you begin to see the scale of the world we live in. Earth is 4.6 billion years old. That is not a number you can easily hold in your mind. It is a span of time so vast that everything we have ever done fits into a single sliver of it, an instant that would vanish if you blinked. That's where the question begins to change, because if the Earth is that old, then why are we so sure that nothing came before us? Not just creatures with claws and teeth, not just forests and oceans filled with strange alien life, but something else, something that could think, build, and leave its mark, if only for a while before time and the planet itself swept it all away. This is not just a story about what might have happened millions of years ago. It's a story about the way the Earth works. Our planet is not a museum. It does not keep its past neatly displayed for anyone to examine. It erases, it recycles. Continents slide across its surface like rafts. Mountains rise and then crumble. Oceans drown entire coastlines and then retreat. If you built a city today and left it untouched, then returned a million years later, you would not find its ruins. You would not even find its dust. You would find bare stone and soil, maybe with a faint chemical shadow deep in the rock and nothing more. And a million years is nothing. If you stretch that to 10 million or 50 or 100, you start to see what deep time really does. Civilizations, if there ever were any before us, would not just vanish, they would be folded into the planet itself, ground down until only the smallest, most stubborn traces remained, hidden in places we have barely begun to look. Scientists have a name for this thought experiment, the Silurian hypothesis. It's not a theory that claims other civilizations existed. It's a question asked seriously and carefully. If there had been an intelligent species on Earth millions of years ago, would we be able to detect it today? And the answer is not simple. Most of the things we think of as proof, monuments, machines, bones, would be gone. Even the tallest towers would have long since crumbled. Roads would be erased. Rivers would change course. Deserts would swallow everything left behind. But some things last longer than stone or steel. When you look at the Earth's history, you don't just see fossils and bones. You see patterns, chemical fingerprints, shifts in the atmosphere, subtle clues that something changed. Even if there is no longer anything left to see, if a civilization burned fuel or mined metals or altered the climate, tiny pieces of that record might still be hidden in the layers of rock. Not clear proof, not something we could point to and say, this is it, but a faint echo of something unusual. Of course, so far, nothing like that has been found. But then again, why would it? We have only studied a tiny fraction of the Earth in detail. Most of the ocean floor is unmapped. Most of the deep rock layers are out of reach. We are creatures living on the surface, scratching at the uppermost layers of a planet that has been reshaping itself for billions of years. If there were older stories, they would be buried far below the places we can see. This is what makes the question so unsettling. We are used to thinking of the world as ours. We imagine history as a straight line that began with us and will end with us. But maybe it isn't a straight line at all. Maybe it is a repeating pattern. Rise, fall, and erasure. Perhaps we're just another brief chapter in a book so long that no one remembers the earlier ones. And yet, this is not a hopeless thought. In a way, it's comforting. Because if there was something before us, then we are not just the product of chance. We are part of a longer story, one that stretches far beyond the reach of our calendars, a story written in stone and silence, waiting for anyone patient enough to listen. Now, of course, none of this means that there were ancient cities under the feet of dinosaurs or hidden machines buried miles underground. If anything did come before us, it would have been erased almost completely. What would remain would not look like a city. It would not even look like a fossil. It would be a thin layer of difference hidden in the rock, something so small that only science could detect it. But even if the chances are low, the scale of time leaves room for wonder. 4.6 billion years is long enough for the unimaginable to happen, not once but many times, long enough for entire worlds to rise and disappear, each leaving nothing but a whisper beneath the soil. And so we start here with this question that has no easy answer. We will follow it downward through the layers of stone and the stretches of deep time. We will look at how the Earth erases its past and how a trace, if it ever existed, might still be hiding there. Because if there is even the smallest chance that we are not the first, then every stone, every layer, every quiet corner of this planet becomes something more than just rock and dirt. It becomes a page from a story older than anything we know. And if nothing else, it reminds us that one day we too will be part of that story. One more layer in the long memory of the Earth. If you want to understand why the question of forgotten civilizations lingers, you have to start with time itself. Not the kind we measure with clocks or calendars, but the deep time that belongs to the Earth. Human history, even at its longest stretch, is nothing compared to it. If you compress the entire history of our planet into a single day, all of recorded human civilization would appear in the last few seconds before midnight. Everything else, the shifting continents, the rising and falling of seas, the births and extinctions of entire species, would pass by in silence long before we ever arrived. And silence is exactly what deep time leaves us. For every 1,000 years that pass, wind and rain eat at mountains, rivers carve new paths, and the land itself moves beneath our feet. The surface of the Earth is not a stable archive, it is a restless canvas, forever erasing what was drawn upon it before. If anything lived and built and thought here millions of years ago, its remains would not be ruins we could walk through. They would be ghosts barely detectable in the chemical memory of stone. We often forget just how much the Earth is erased. Consider the simple fact that there is almost no surface left from the earliest chapters of our planet's history. The ground we walk on is young compared to the planet itself. Most of the original crust has been recycled by plate tectonics, pushed down into the mantle, melted and remade. Entire continents have come and gone, colliding and breaking apart. Ancient mountain ranges have risen to towering heights and then worn away until nothing remained but low hills and buried roots of stone. If a civilization existed in some remote age, how could it have survived that kind of planetary churn? It likely couldn't. Even fossils, the most durable remnants of life, are rare. We only know a fraction of the species that once lived here because most left no trace at all. For every perfectly preserved skeleton in a museum, there are countless others that were destroyed, buried too deep, or never fossilized in the first place. Now imagine not just bones, but buildings and tools. Those would be gone in a fraction of that time. Yet there are other ways that the past leaves its mark. When we study the layers of rock, we find more than fossils. We find a spike of iridium in a layer of clay that tells the story of the asteroid that ended the age of dinosaurs. Bands of iron in ancient stone record the oxygenation of the atmosphere billions of years ago when life itself transformed the planet. These are the kinds of traces that endure. Not objects, not ruins, but evidence written in chemistry, pressed into the earth like faint fingerprints that never fully fade. If an earlier civilization left anything, this is where it would be. Not in some hidden city buried under sand, but in the rocks where time itself has sealed it away. Perhaps there would be a sudden change in the balance of carbon isotopes caused by industry. Perhaps rare metals would appear in unusual concentrations, the byproduct of mining or technology. These would not be obvious at first glance, but in the careful hands of geologists, they would stand out like quiet, unexplainable intrusions. And even then, the evidence might be so subtle that we would not recognize it for what it was. After all, we're only just beginning to learn how to read the planet's deep history. A century ago, we didn't even know how to measure the age of rocks. We had no idea that Earth had passed through multiple mass extinctions, or that vast portions of its surface had once been covered by ice or tropical seas. Every generation adds a few more pages to the book of deep time, but most of it is still unread. This is why the ghosts of forgotten time are so easy to overlook. They do not stand in plain sight. They hide in the parts of the world we rarely see. The deep ocean floor, the buried cores of ancient mountain ranges, the vast stretches of desert where wind has scoured away the younger layers to expose fragments of the older ones beneath. These are the places where the Earth still carries its oldest memories. And even there, those memories are faint, fractured and scattered. What makes it even stranger is that in a way we are ghosts too. If someone or something were to come after us millions of years from now, they would not see the world we know. They wouldn't find our cities standing proud against the horizon. They wouldn't walk through our libraries or touch the screens we stare at every day. They would see a thin, peculiar layer in the rocks. Perhaps they would find traces of metals where no natural process should have put them. Maybe they would see the shadow of our brief reshaping of the atmosphere, but that would be it. That would be our ghost. The idea feels strange because we are used to thinking of ourselves as permanent. But the Earth does not share that view. It buries its past without hesitation. It has done it before, and it will do it again. Every footprint, every structure, every trace of our lives is temporary. And if that is true for us, it must also have been true for anything that might have come before. This is what makes the question of a lost civilization so haunting. It isn't just about them. It's about us too. It forces us to imagine the planet not as a stage built for our story alone, but as something older, stranger, and far less concerned with who happens to be living on it at any particular moment. We're only here for a little while, then we fade, and the Earth goes on carrying its secrets beneath layers of stone. And maybe that's why the thought is both unsettling and strangely calming, because if there were others before us, they are not so different from what we will one day be. A layer in the rock, a few faint signals in the planet's deep memory, nothing more and nothing less. But before we let that thought settle too deeply, we should look at how those memories are made and how easily they can vanish. Because if we want to understand the ghost of forgotten time, we have to understand the forces that bury them. If the Earth is so skilled at erasing its past, then all that remains for us is to imagine what might have been, not in the way fiction does with towering alien cities and impossible machines, but in the quiet, grounded sense of what life could realistically have produced given enough time. We often think of ourselves as unique, but evolution has no rule that says intelligence happens only once. Life has been experimenting here for billions of years. It has built creatures with armor like stone and others with skeletons as light as air. It has shaped predators that ruled the seas for hundreds of millions of years, only to see them vanish overnight in the wake of some cosmic disaster. If intelligence emerged once, ours, then perhaps it could have emerged before in a form that left only the faintest echoes behind. Consider the simple fact that mammals were not always the dominant force on this planet. For most of Earth's history, reptiles ruled the land and oceans, while strange bird-like creatures filled the skies. Before them, there were vast ages dominated by creatures even stranger, fish with jaws like traps, forests of towering plants that resembled no trees we know today, and insects so large they could have cast shadows over our heads. Intelligence, if it ever arose in these eras, would not have looked anything like us. But it would not have needed to. A mind capable of understanding its world does not have to wear a familiar shape. Some scientists have even pointed out that dinosaurs, given enough time, might have evolved forms far more complex than the ones we know from fossils. It is speculation, of course, but then again, so is the assumption that intelligence could never have happened before us. If natural selection can produce flight, sonar, and bioluminescence, why not problem-solving brains in a world long gone? Perhaps not in every era, but once, somewhere, when conditions allowed. If such a civilization did exist, it likely would not have followed our path. We imagine cities because that is what we know, but perhaps they lived in ways that left little to no trace. Maybe their technology was not built of metal and stone, but from materials that decayed as quickly as wood or bone. Perhaps they mastered their world in ways that never required the kind of industrial scars we now leave across the planet. If that were the case, their presence could have passed into the Earth almost without a footprint, their story ending in silence long before our first ancestors ever stood upright. Even if they did change their world in ways more like ours, there is still the matter of time, A million years is enough for mountains to erode away. 10 million can drown continents beneath the sea. 50 million can transform the very shape of the planet. If an ancient civilization flourished and then fell, their remnants might have been buried so deeply, or destroyed so completely, that no trace of them would remain within reach. All that would be left is the idea that they might have been. And yet there are faint, unsettling moments when we find things in the earth that don't quite fit. Objects turned up in mines that look oddly shaped. Stones split open to reveal patterns that seem deliberate, but are only the tricks of geology. They are not proof. Most are explained and the rest are likely illusions born from coincidence. But they persist in our imagination because they tap into something older than evidence, the quiet sense that this planet has had more time than we can truly understand, and that anything that long lived must be full of hidden chapters. Even our own existence fits neatly into this pattern. We've been here for only an instant, and yet we're already leaving signals that could last millions of years. Our metals, our plastics, our sudden and unnatural chemical fingerprints, they will be pressed into the rock like a message for anyone who might come after us. If we can do that in a fraction of the Earth's history, then who's to say it has not happened before? And maybe if it did, we would not even recognize it. If a civilization had emerged 50 million years ago and left traces we cannot read, we might simply look past them, thinking they are nothing but the ordinary marks of nature. For all we know, we have already walked over them. We may have cut through their last surviving fragments while digging for highways or drilling for oil, never realizing what we destroyed in the process. That is the humbling part of this question. It forces us to imagine that we are not just latecomers to this world. We might also be forgetful heirs living on a planet that has already had other tenants. The Earth is old enough to have forgotten them, but not so old that it couldn't happen again. And that possibility, quiet though it is, changes the way we see the ground beneath our feet. Because the next time you look at a stretch of empty desert, or stare out at the deep dark ocean, or see the jagged bones of ancient mountains, you might remember that this world has had more than one story. Ours is only the one we know, but there may have been others, older than memory, erased by time until all that remains is the faintest whisper in the stone. And if that whisper is there, then somewhere hidden in the deepest places, the Earth may still be keeping their secrets. If there is one thing the Earth does better than anything else, it is forgetting. We like to think of the planet as a kind of vast library, its layers of stone holding the record of everything that has ever happened. But in truth, it is more like a restless editor, constantly rewriting, tearing pages out and covering old words with new ones until only a few scattered fragments remain. To understand why, you have to look at the way this world works. The ground beneath your feet might feel solid, but it isn't. It is a thin, shifting crust broken into great slabs called tectonic plates, which drift across the surface of the planet like slow-moving rafts on a deep, hidden sea of molten rock. These plates crash together, pull apart, and slide past one another in an endless cycle that has been running for billions of years. Mountains rise where plates collide, oceans open where they drift apart, and in the process the surface of the Earth is recycled again and again. This is why almost no surface rocks are truly ancient. The ground you walk on is young compared to the planet itself. Most of it has been built, destroyed, and rebuilt countless times. If you go back far enough, hundreds of millions of years, you find that the continents were in different places, the oceans were different shapes, and even the air we breathe was not the same. Whatever might once have been written on the surface has been buried or erased entirely. Imagine for a moment a city built today. If it were abandoned and left to the mercy of the elements, it wouldn't take long for nature to reclaim it. In a few hundred years, vegetation would break through the concrete, roofs would collapse, rivers would shift and flood streets that were once paved and clean. In 10,000 years, you might still find scattered remnants, stone foundations, fragments of metal, but give it 1,000,000 years, and all of it would be gone. Now, stretch that timeline even further. 10 million years, 50, 100, the continents would have shifted. Mountains might have swallowed the land where the city once stood, or it could have been dragged under an ocean trench and pushed down into the deep mantle where heat and pressure would grind it into its most basic elements. At that scale, the very idea of ruins becomes meaningless. Nothing lasts that long. This is why, if a civilization ever came before us, the Earth itself would be the reason we cannot see it. Even fossils, the hard evidence of life, rarely survive more than a few tens of millions of years. What survives is only a fraction of a fraction. The lucky pieces sealed in the right conditions at the right time, and those are only bones and shells protected by chance. The traces of a civilization would have to survive far more hostile treatment. Geologists sometimes talk about unconformities, gaps in the rock record where millions of years are simply missing. These gaps exist because erosion stripped the surface clean before new layers were laid down. Imagine erasing entire chapters of a book and then continuing the story as if nothing had been lost. That is what the Earth does over and over again. If an ancient civilization once stood on one of those erased surfaces, every trace would be gone, swept away before the next page was written. And yet, not everything is lost. Some things sink down and are buried deep, sealed off from wind and water, but even then they are not safe forever. Plate tectonics drags rock downward. Heat and pressure transform it. Sediments become stone. Stone becomes magma, and magma cools to make new crust. It is a cycle of destruction and renewal, and it has been running for billions of years. If we disappear tomorrow, the planet would do the same to us. This is why when scientists look for signs of deep history, they don't look for artifacts, they look for chemical clues. The asteroid that ended the age of dinosaurs did not leave behind a visible crater we could easily see until modern tools found it. But it left a layer of iridium in the rock, scattered around the world, a chemical fingerprint so strange that it could only mean something extraordinary had happened. In the same way, if there was ever a civilization before us, it might not be remembered in ruins or tools, but in chemistry. Small anomalies frozen in stone waiting for someone with the right knowledge to notice them. But the truth is, we have only read a handful of these pages. Most of the ocean floor where traces might hide is less than 200 million years old, because it is constantly recycled back into the Earth's interior. Anything older than that has been erased completely. On land, the story is only slightly better. We have rocks that are billions of years old in places, but they are rare, and they are often so altered by heat and pressure that they can no longer hold the fine details of what once happened there. This is what it means to live on a restless planet. The ground beneath us feels stable only because it moves too slowly for us to notice. But given enough time, everything shifts. The continents we know today, Manafrica, Asia, the Americas, Europe and Australia, are only temporary arrangements. In another 100 million years, they will be in completely different positions, welded together into new supercontinents or scattered apart again. Whatever is built in our time will either be carried along or swallowed whole. When you look at the Earth this way, you start to see why the absence of evidence is not proof of absence. It's not that there couldn't have been anything before us. It's that this world is very good at cleaning itself. 100 million years is long enough to wipe the slate almost completely clean, leaving only the faintest clues in places we have barely begun to search. And yet, for all this erasure, there is still a chance that something might remain. Somewhere buried deep in a forgotten layer of rock, there could be a trace, a chemical oddity, a concentration of metals, or a pattern that doesn't quite match any natural process. Not proof, not a message, but a ghost. And if we ever find such a ghost, it might be the only voice left from a world that came and went before we ever knew it existed. The question is whether we are ready to look for it. Because once you accept how easily the Earth erases its past, you start to realize how many other things it might have erased as well. And that thought lingers because if the planet has done this before, it will do it again. One day, long after we are gone, our cities will be ground to dust. Our machines will vanish and our story will be folded into the same stone pages that hold everything else. One day we will be nothing but another faint line in the rock waiting for someone, if there is anyone left, to wonder who we were. The more you think about how completely the Earth erases its past, the more a certain question begins to take shape. It is not just a passing idea. It has a name given to it, not by dreamers or science fiction writers, but by serious scientists, who decided that if nothing else, it deserved to be asked. They call it the Silurian hypothesis. The name comes from an old science fiction story, a playful nod to a fictional species of intelligent reptiles who are said to have lived on Earth long before humans ever appeared. But behind the light-hearted title is a serious thought experiment. If an industrial civilization had risen on Earth millions of years ago, how would we know? And perhaps more unsettling, would we even be able to know at all? This is not a theory that claims there was one. It is not evidence that points to some forgotten species that came before us. It is a test, a way of asking whether our methods of studying the Earth's history are good enough to rule out the possibility. Because if they are not, then we are forced to admit that the question must remain open, if only in the faintest, quietest way. When scientists first proposed it, they started from a simple observation. Our own civilization is already leaving signals that will last far longer than we will. We burn fossil fuels, and in doing so, we change the balance of carbon in the atmosphere. Those changes will be pressed into the rock record, a chemical signature that could persist for millions of years. We spread metals across the surface of the planet in patterns that do not exist in nature. We produce synthetic compounds that no volcano or ocean current could ever make. Plastics, for example, might eventually break down into microscopic fragments, but some of those fragments could be buried and locked into the sediment, sealed away like strange little time capsules. If we vanished tomorrow, the Earth would cover us up, grind us down, and erase our cities. But those deeper signals would remain, hidden in the rocks, waiting for someone with the tools and knowledge to find them. And if we can do this in just a few centuries of industry, then the question naturally follows, what if someone else did it before us? The scientists who first outlined the Silurian hypothesis, Gavin Schmidt and Adam Frank, approached it carefully. They knew it would sound strange, and they were not arguing that it happened. Instead, they asked a sharper question. What would the evidence look like if it did? And just as importantly, how long would that evidence survive? The answer they found was both reassuring and unsettling. Reassuring because our own impact on the Earth will indeed leave a lasting mark. Unsettling because that mark would be hard to recognize if you didn't already know what to look for. Imagine a layer of rock 50 million years from now. If someone were to split it open and analyze it, they might find a sharp spike in certain metals, copper, aluminium, lead, spread out in concentrations that no natural process could explain. They might see a sudden shift in the carbon isotope ratios, the frozen signature of a brief intense period when something on this planet burned through enormous amounts of stored carbon. They might even find traces of synthetic molecules, long degraded but not entirely gone. And what would they conclude? Would they see it for what it was, a sign of an industrial civilization long vanished? Or would they mistake it for some strange but natural event, a quirk of volcanic activity or ocean chemistry? Without context, without a clear trail of artifacts or fossils, it might be nothing more than an oddity in the rock, and then they might move on, leaving the question unanswered. This is what makes the Silurian hypothesis so powerful. It forces us to admit that even if there were another civilization before us, we might not recognize it, because the planet is too old and its memory too broken. In fact, we might already have looked past such evidence without realizing it. And yet there are places where this kind of search could begin. Deep ocean sediments, for example, are some of the best archives of the Earth's history. They collect layer after layer of material, year after year, quietly recording the chemical state of the world above. If an ancient industrial age ever existed, its fingerprints might still be hidden there, buried miles beneath the sea. We could also look at ancient coal seams or other fossil fuel deposits. If a civilization used energy the way we do, it might have left strange gaps in those deposits or odd chemical signatures where it altered the balance of the environment. Even patterns of erosion or unexpected mineral concentrations in ancient rocks could be clues, though they would be difficult to distinguish from natural processes. The unsettling truth is that if we are serious about answering this question, we would need to look not for monuments, not for machines, but for subtle irregularities, signals faint enough to be overlooked, unless you already suspect they might be there. And that perhaps is why the Silurian hypothesis lingers in the imagination. It is not about believing in lost cities or forgotten empires. It is about humility. It is about admitting that on a planet this old, our own story is too small to be the measure of all things. We're a single chapter in a book that began billions of years ago, and most of its earlier pages have been destroyed. If we're willing to read between the lines of what remains, perhaps we might catch a glimpse of something older. But even if we never do, the exercise changes us. It reminds us that our time is fleeting, that the Earth has seen more than we can ever know, and that one day our own chapter will be reduced to the same kind of quiet chemical whisper that future eyes may or may not notice. And if there is a lesson in that, it might be this. If we want to be remembered even by a world without us, we should pay attention to the marks we're making. because time will not preserve our towers or our roads. It will only preserve what we leave in the bones of the Earth itself. If the Silurian hypothesis teaches us anything, it's that time is merciless. It reduces everything to fragments, and even those fragments must fight to survive. Yet, if there was ever a civilization before ours, some part of it might still remain, not in the form of standing ruins or recognizable tools, but as what you might call fossils of fire and steel. These would not be fossils in the way we normally use the word. You would not find them displayed in a museum or held up under glass. They would be hidden deep in the earth, stripped of all shape and identity, reduced to their most basic traces, but they might still be there, waiting in silence, small clues in the vast archive of stone. When we look at our own world, we can already see the beginnings of what we would leave behind. Consider steel. Every bridge, every ship, every high-rise is built on it. If our cities were abandoned and left to time, those great skeletons of steel would not remain standing for long. Rain and wind would eat at them. Oxygen would tear at their surfaces. Within a few thousand years, they would crumble into flakes of rust and sink into the ground. But even then, some part of them might be carried away by rivers, buried in sediments and pressed under new layers of rock. Given enough time, those fragments could become something else entirely. They might turn into tiny seams of iron-rich stone, an unremarkable feature, indistinguishable from natural deposits unless you knew how to look closely. And yet those seams would not be random. Their chemistry would carry a signature, traces of the alloys we once used, the nickel or chromium mixed into our steel, locked in place like the faintest whisper of what we once were. The same is true for copper. We mine it, shape it, and spread it through every wire and circuit on the planet. If we vanish, the copper would oxidize, tarnish, and eventually sink into the soil. Over millions of years, it might be swept into streams, buried, or drawn down into deeper layers of rock. But it would not vanish. Nothing in nature would remove it. And if another intelligence ever came along to study the Earth, they might see in the deep record a sudden and unnatural pulse of copper concentration, not a vein formed by heat or pressure, but a scattered thin layer left by a world that lived and died long before them. And then there is fire. Industrial civilization runs on it. Every barrel of oil burned, every ton of coal turned to ash, changes the chemistry of the atmosphere. Those changes don't just disappear, they become part of the Earth. The carbon we release today will be trapped in stone for millions of years. Geologists of the far future, if any exist, will be able to see it the way we now see the iridium layer left behind by the asteroid that killed the dinosaurs. It will look sudden, it will look strange, it will be a signal that something happened. Even our plastics, fragile as they seem, might leave their own strange legacy. They will break down. Yes, sunlight and bacteria will shred them into smaller and smaller pieces, but some of those pieces will be carried into the deep ocean, where they will settle into sediments beyond the reach of waves or weather. Buried there under layer upon layer of silt, they might persist as microscopic fossils, small, stubborn reminders that once, long ago, something on this planet learned how to make materials that nature never would. If this is true for us, then it could be true for anyone or anything that came before. Maybe their traces are there already, buried in the rocks we walk on, disguised as natural features we have never thought to question. A spike of metals here, an odd chemical ratio there, not enough to rewrite what we know, but enough to make a patient observer wonder if the Earth is holding secrets it has never shared. Of course, it is just as likely that if another civilization existed, its traces have been destroyed completely. Time is not kind, and most of what lives on this planet vanishes without leaving a mark. But that is exactly why the search for these fossils of fire and steel matters, because if we know what to look for, these quiet signals buried in stone, we might one day be able to tell whether our planet has been a stage for only one act or many. And in a way, this search is also a mirror. When we imagine what evidence a past civilization might have left behind, we're also imagining our own future. What will remain of us when the last skyscraper has fallen and the last city has turned to dust? A thin line of altered chemistry in the rocks, a scattering of metals where they should not be, perhaps a faint layer of microplastics pressed into the deep seabed, like a signature written in a language no one will ever read. It's humbling to think about. Everything we have built, everything we call progress, reduced to a geological oddity, and yet in that oddity there is something almost comforting, because even if the Earth forgets our names and our monuments, it will still remember us in its own way. We will become part of the stone. We will join the long record of this planet, as every living thing eventually does. And if that record includes more than just us, if there were others before us, then perhaps they are there already, layered beneath our feet. Not cities, not bones, just the quiet, unassuming fossils of fire and steel. And if that is true, then every rock we split open, every deep core sample we drill from the ocean floor, is not just a study of the past, it's a chance to listen, just for a moment, for the faintest echoes of civilizations that might have come and gone long before the first human ever opened their eyes. And if those echoes are there, the Earth is still holding them as it has held everything else, deep in its memory of stone. If the Earth hides its past in stone, then the deserts of the world are its quietest vaults. There is something about the stillness of sand that feels almost timeless, as if the wind itself has been sweeping across the same empty spaces forever. But deserts are not empty. They are places of burial. They are where the world stores what it does not want us to see, sealing it away grain by grain until nothing remains above the surface but silence. Even in our own brief history, we've seen this happen. Entire cities have been swallowed by sand in a matter of centuries. Once bustling trade hubs in North Africa, towns along forgotten caravan routes, temples abandoned when the rivers that fed them dried up. Gone, hidden beneath the shifting dunes. The desert does not destroy them outright. It simply covers them, it waits. If that is what can happen in only a few thousand years, what might the desert hold after millions? When you stand on the edge of a vast desert, it's easy to feel as though you're looking at a place outside of time. The Sahara, for instance, stretches across more than 3 million square miles. But it was not always like this. Just 10,000 years ago, it was green, full of lakes and rivers, teeming with life. People lived there. They left rock paintings of elephants, giraffes, and hippos, animals that now survive only in Africa's wetter heartlands. Then the climate shifted, the rains withdrew, and the sand came. Now imagine that same transformation, not over thousands of years, but millions. Whole landscapes vanish under dunes, mountains erode. Whatever was there before, whether it was villages, forests, or something else entirely, would be lost under a blanket of sand so deep it might as well be the bottom of the ocean. This is what makes deserts such strange places in the search for lost history. On one hand, they erase. Wind scours the surface. Sand abrades and buries anything left exposed. But on the other hand, that very same burial can preserve. Once something is covered deeply enough, the desert seals it away. No rain, no plants, no roots pushing down through the soil, just dry, relentless stillness. We've already seen this in archaeology. The dry air of the Sahara and the Middle East has preserved things that would have rotted away anywhere else. Papyrus scrolls, textiles, even the fragile footprints of people who once walked across wet ground that turned to dust and never saw rain again. The desert can be harsh, but it is also patient. It can hold on to things far longer than the living world outside it. And that raises an unsettling thought. If our own world could leave such traces in deserts after only a few thousand years, what might lie much deeper down, sealed away from the age of humans entirely? Could there be remnants not of us, but of something far older, buried so deep beneath the sand that we would never know to look? It would not be cities as we imagine them, not streets or walls or glass towers. Time would have erased their shapes long ago, but the materials, the raw matter of a civilization might still be there in some transformed way. Strange concentrations of metals, microscopic traces of compounds that should not exist, fossils of industry pressed into layers of sand turned to stone. Most of the desert floor is far older than anything we have built. Beneath the dunes of the Sahara, for example, are rocks hundreds of millions of years old. Their surface is buried and unbroken for longer than we can easily imagine. If there were ever anything there before us, it would not be at the surface, but deep in those ancient layers far below where our shovels and ground-penetrating radar have reached. And perhaps that is the most humbling part of this question. We think of deserts as empty. We look across them and see nothing but sand and sky, but to the earth they are vaults, quiet, sealed chambers holding pieces of the past that we do not even know how to ask about yet. We might never dig deep enough to find out. The planet is simply too big and the sands too wide. Even our most ambitious archaeological projects scrape only the uppermost layers of the world, skimming across a surface that hides almost everything that came before. But the possibility lingers. It lingers because the deserts are so silent, because they are so good at hiding what has been given to them. And if in some forgotten age, another civilization left its traces here, this is where some of them might still be waiting. We will probably never know for certain, but every time the wind shifts and the sand moves just enough to uncover a new fragment of history, an ancient tool, a buried carving, a long-lost settlement, it is a reminder that the desert does not only erase, it also remembers. It keeps its secrets until the day comes when the world is ready to see them again. And if it can do this for us, for our small and recent history, then perhaps it has been doing the same thing for much longer than we have been alive to watch it. And so we look at the dunes and we wonder, not because we are certain of what is buried there, but because the silence is too deep not to imagine what it might be hiding. If the deserts are vaults of silence, then the oceans are something even stranger. They are the planet's true archive, vast, cold, and almost untouched by time. While wind and rain scour the land and continents are ground down and rebuilt, the deep ocean simply takes what falls into it and hides it away. Most of the Earth's surface lies beneath those waters, yet we know almost nothing about what is down there. We have mapped the seafloor in broad strokes, tracing the ridges and trenches, but most of it remains unvisited, unexamined, and unstudied. And that is where the deep ocean becomes so important to this question. Because if anything from a forgotten age has survived the endless rewriting of the continents, this is where it might be. On land, erosion is relentless. Mountains crumble, rivers carve valleys, glaciers scrape landscapes clean. Even the hardest stone is eventually broken down, buried, or transformed by heat and pressure. But in the deep ocean, far below the surface, none of that happens. There is no weather to wear things away, no plants digging their roots into the ground, no constant churning of the surface, only darkness, cold, and the slow, steady fall of sediment. Year after year, tiny particles drift down from above, dust from continents, ash from distant volcanic eruptions, fragments of life from the upper layers of the sea. They settle on the ocean floor in thin, delicate layers. Over thousands of years, those layers stack up one atop another until they become the seafloor's quiet memory of the world above. This is why scientists drill into the deep ocean to study Earth's past. Cores pulled from the seabed hold an unbroken record, stretching back millions of years. In them you can read the history of ice ages, mass extinctions, and ancient climates, written not in words but in chemistry and sediment. Each layer is a page laid down slowly and never erased. If an ancient civilization ever left its mark on the planet, this is where we would look for it. Not in ruins, not in artifacts, but in those thin, steady layers of ocean mud. What would we expect to find? Not much, at least not in the way we usually imagine evidence. There would be no sunken cities, no intact machines waiting to be discovered. The ocean is not kind to such things. Its waters corrode, crush, and bury anything that lingers too close to the surface. But what the ocean does preserve are signals, the same kind of subtle chemical traces that the Silurian hypothesis describes. Imagine a layer in an ocean core where something unusual appears. Perhaps there is a spike in metals that do not belong, scattered across the world's seabeds all at once. Perhaps there is a sudden shift in the balance of carbon isotopes, the kind of shift that can only come from burning vast amounts of fuel. Maybe there are fragments of long-broken synthetic compounds too degraded to identify, but strange enough to raise questions. That is what a forgotten civilization would look like after tens of millions of years. A line in the ocean floor, a chemical scar in the sediment. You wouldn't see it unless you were searching very carefully. You might drill 1,000 cores before finding even a hint of it. But if anything from that deep past could still be there, the ocean is where it would be hiding. And yet, this is the part that humbles us most. We have barely touched this archive. The ocean covers more than 70% of the Earth, and almost all of it remains unexplored. We have mapped the stars in greater detail than we have mapped the ocean floor. We have walked on the moon, but we have not seen most of our own planet. This is why the question remains open. We do not know what is buried beneath the sediment, because we have never truly looked. We take cores in a few scattered places. We examine what we can reach, but most of the deep ocean is left alone, silent and unknowable, holding whatever it has been given across millions of years. And what it has been given could include things we do not expect. We already know that the ocean floor holds the record of ancient disasters, the thin clay layer that marks the asteroid impact that ended the age of the dinosaurs, the traces of massive volcanic eruptions that once smothered the planet in ash, the chemical signatures of sudden violent changes in the atmosphere. These things survive in the deep because nothing touches them. They are left alone in that cold, dark stillness, untouched by the rest of the world. If those things can remain, then so might something else. Not proof, not certainty, but a possibility, a reminder that if there ever was an age before ours, an age of fire and industry that came and went long before the first humans looked up at the stars, the deep ocean might be the only place left where its shadow could still be hiding. And so we look at the sea not just as a wilderness, but as an archive. Every wave that laps against the shore, every tide that comes and goes is connected to something far vaster, far older, and far quieter than we can easily imagine. The ocean has been keeping its secrets for a very long time, and if it is holding one more, the ghost of a civilization that came before us, it will keep it until we are ready to look deep enough to find it. If you want to understand just how much the Earth can hide, you have to do something strange. You have to take everything you know about time and run it backward. Imagine peeling away the years one by one, not just centuries or millennia, but millions of years until our cities, our roads, and even the shapes of our continents begin to dissolve. The first layers come off quickly, a few thousand years gone, and every building you know is already erased. Forests spread where neighborhoods once stood. Rivers meander freely again, erasing the last straight lines we carved into the landscape. 100,000 years and not even a shard of glass or rusted fragment of steel remains on the surface. Go back 1,000,000 years and you would not recognize the world at all. Ice sheets advance and retreat. Species you've never seen roam the land. The air itself has shifted, its composition rewritten by the slow-breathing rhythm of the planet. Humans are no longer in the picture. What's left is a wilderness, an Earth untouched and unmarked as if we were never here. Now keep going. 10 million years, 50, 100. The continents drift across the face of the globe. Entire mountain ranges rise and crumble to dust. Oceans vanish and are born again in new places. Volcanoes pour out enough lava to bury whole regions, and anything that once stood upon the surface is either pulverized or dragged down into the mantle, recycled into the deep machinery of the planet. This is what happens when time runs backward. You don't just erase what exists now. You erase the very ground it stood on. You strip away the familiar continents until even they become strangers. You reach a point where there is no where left to speak of because the land itself has been scattered, buried, or reborn. It's here that the question of ancient civilizations takes on a new weight. Because if we can run time backward and watch our world disappear layer by layer, then why not imagine that the same thing could have happened before? Why not imagine other rises and falls hidden beneath those vanished pages of Earth's history? Scientists sometimes describe the planet's crust as a palimpsest, a manuscript written and rewritten so many times that only fragments of the earlier words remain. We see those fragments in places like Greenland, where pieces of ancient rock more than 3 billion years old have survived by sheer accident, protected from the relentless recycling of the rest of the planet. They are windows into a time so remote it feels almost unreal. But even in those ancient rocks, most of the record is missing. It's as if the book of Earth's history has been torn apart with only a handful of scattered pages left to us. Mass extinctions, asteroid impacts, and climate upheavals are written there. Yes, but they are just glimpses separated by enormous blank spaces where time has erased everything else. If there had been a civilization in one of those blank spaces, within as 10 million years before the dinosaurs or 50 million years after the first forests, how would we know? The answer is simple. We wouldn't. We would only see what we see now. Fragments. A few lines in a script that has been mostly scrubbed clean. And this is not just imagination. We know the Earth has erased almost everything before. Take the Permian-Triassic extinction, the greatest die-off in the planet's history. 90% of all species vanished. And yet the geological record of that event is thin, a subtle layer of clues spread across the world. If something as catastrophic as that can be reduced to a few chemical signatures in the rocks, then what chance would a brief intelligent civilization have of leaving a clear trace? When you run time backward far enough, you also see how small our own chapter is. Human civilization has lasted only a few thousand years. Industrial society, the kind that could leave detectable traces, has existed for little more than 2 centuries. Compare that to the age of the Earth, and you realize how narrow the window is. If there were others, they might have appeared and vanished, so long ago that the planet has already folded their story into its deep, silent archive. This is why some scientists argue that our best chance of finding evidence for such a civilization would be indirect. Not artifacts, not ruins, but chemical oddities, signals of something that briefly disrupted the planet before vanishing. And even then, those signals might look no different from a natural event. A burst of carbon in the atmosphere could be mistaken for volcanic activity. A spike in metals might look like nothing more than an unusual geological formation. Without context, how would we ever tell the difference? And so, when you let time run backward in your mind, you come to a strange conclusion. The absence of evidence is not proof that nothing happened. It is only proof that the Earth is better at forgetting than we are at finding. But there's another side to this thought, and it's the part that lingers longest. If time can erase everything that came before, then it will also erase us. 100 million years from now, if the world is still here, no one will walk through the ruins of our cities. No one will see the shapes of our buildings, or even know the names of the places where they once stood. All of it will be gone, folded into stone and ocean, just as it has done to everything else. And in that thought there is a kind of strange equality. If there were other civilizations before us, they are gone, erased without a trace. One day we will join them, and maybe in some far future we will never see, someone else will look at the Earth the way we look at it now, and wonder if they are the first or if there are ghosts hidden in the stone waiting for anyone patient enough to listen. Time does not move for us, we move through it, carried forward while everything behind us sinks deeper into the dark. But if you run it backward just for a moment, you can almost see how it all disappears, one layer at a time until nothing is left but the quiet, empty Earth, waiting for its next story to begin. If there is one thing the Earth has always done, it is speak. Not in words, not in sounds we can hear, but in a language far older than we are, a language of stone, pressure, and time. The problem is not that the Earth has no story to tell. The problem is that we're only just learning how to read it. Look at a rock. To most people, it is just a rock, solid, silent, and unchanging. But to a geologist, that same rock is a page in a book. Its minerals, its structure, even the way it fractures can reveal where it came from and what happened to it across millions of years. A piece of sandstone is not simply stone. It is an old riverbed or the floor of a vanished sea. A layer of volcanic ash is not just dust turned to rock. It is the frozen memory of an eruption so violent it could have darkened the skies for years. Every stone carries a record, but it is written in a script that is slow, subtle, and easy to miss. You have to know how to look. When scientists split open layers of ancient rock, they are not just examining minerals, they are studying the history of the world itself. Ice ages, warm periods, great floods, and even the faint signatures of mass extinctions, all sealed inside what looks to most of us like nothing more than dull grey slabs. And it is in this language that any trace of a civilization older than ours would be written, not in ruins or monuments. Those would be erased, but in the deep chemical fingerprints left behind in stone, a thin layer of unusual metals, a shift in carbon ratios, perhaps even strange compounds that nature alone could not create. These would be the only words such a civilization could leave behind, and they would be written in the quiet, patient script of geology. This is why the Earth can be both a destroyer and a keeper of memory. It erases what we expect to see, but it preserves what we do not think to look for. The asteroid impact that ended the age of dinosaurs left almost nothing we could touch or hold. There are no shattered pieces of the asteroid itself lying around for us to study. But the Earth left us a single thin layer of iridium-rich clay spread like a fingerprint across the entire planet. That one layer told the story. It was enough. If we vanished today, our story would not be told through our cities or our machines. It would be told the same way, through the strange residue of our presence, locked into stone for as long as the Earth is willing to keep it. Future eyes, if there are any, would not find our streets, but they might see the metals we scattered, the isotopic scars of our industry, and the faint stubborn traces of plastics turned to dust and sealed in the deep sediments of the ocean. Now imagine that same kind of evidence, but from 100 million years ago. Imagine it buried deep in rock so subtle that it looks like nothing more than an oddity in the data. Would we even recognize it for what it was? Or would we dismiss it as noise, a quirk of nature that we do not yet fully understand? This is the quiet challenge of the language of stones. It does not shout. It does not explain itself. It only whispers, and you have to decide if what you are hearing is real or if it is only in your imagination. Most of the time it is easier to look away, to accept that the story we can read is the only one there is. But every so often you come across something, an anomaly, a small inexplicable signal, and you wonder if the Earth is trying to tell you there is more to the book than the chapters you already know. And this is not just a question for lost civilizations. It is also a reminder of how limited our view of the past truly is. For every layer of stone we can read, there are countless more that we will never reach. Most of the record is buried deep underground, inaccessible to us without technology we do not yet have. It is like standing at the edge of a library so vast that you can only read the first few pages of a single book and guessing what the rest of the shelves contain. But that is also what makes it beautiful. Because even though we cannot read it all, we know the language exists. We know that the Earth remembers in ways that we do not. And if there was ever anything before us, if there was ever a time when something else walked this planet and left its mark, the Earth has not forgotten completely. It may have buried it, rewritten it, folded it deep into the crust, but it has not erased it entirely. And that means that every stone we study, every layer of sediment we drill from the bottom of the ocean, is a chance to listen a little closer. Because one day we may find that the Earth has been holding a secret, not out of malice or mystery, but simply because it has always spoken in a language too slow for us to hear. The question is whether we are patient enough to keep listening, because if we are, then maybe one day the stones will answer. Every now and then, as we study the Earth's deep past, something surfaces that doesn't quite fit. Most of the time it's nothing. A strange rock formation mistaken for a tool, a natural pattern that happens to look deliberate. But every so often, there are stories, objects, and discoveries that seem to whisper of something older, something that should not be there at all. They're called out-of-place artifacts. Most are explained in time, their mystery worn down by closer study. But the idea of them lingers because it speaks to something deep in us, the suspicion that the world is older and stranger than the history we have written for it. Take, for example, the so-called London hammer, a hammer-like object found encased in stone. At first glance it seemed impossible, a tool sealed in rock that according to its surrounding material was millions of years old. The story made headlines. It was passed around as proof of something extraordinary. But when examined carefully, it turned out to be far less mysterious. The stone around it was not ancient bedrock but a concretion, a relatively young formation of minerals that had built up around the object over time. The hammer wasn't a relic from a forgotten age. It was simply a misplaced tool wrapped in a misleading coat of stone. Most of these artifacts follow the same path. They begin as sparks of wonder, small challenges to the world we think we know, only to be explained away by the slow, patient work of science. And yet, even after the explanations settle in, the idea remains. Because what if, just once, one of those sparks turned out to be real? Even scientists who reject the wild claims admit that the question itself is not absurd. Not because there's evidence of ancient machines or tools buried deep in the earth, but because we know how incomplete the record is. For every fossil we have, millions more have been lost. For every ancient site we've uncovered, countless others have been swallowed by the shifting surface of the world. If there were artifacts from a forgotten age, whether natural or not, most of them would be gone, but not necessarily all. And that is what keeps this possibility alive. Because the truth is, the line between the explainable and the extraordinary is sometimes very thin. A single stone tool out of place by only a few million years could rewrite everything we know. A single manufactured object found in undisturbed rock could open a door we didn't even know was there. The Silurian hypothesis reminds us that if there was ever a civilization before us, its legacy would not be obvious. It would be scattered, transformed, and almost impossible to recognize. Its artifacts, if any survived, would not look like our artifacts. They would not be pristine machines or perfect carvings. They would be lumps of alloy weathered beyond recognition. They would be microscopic residues locked inside ancient rock. They would be things we would walk past 100 times never realizing what they were. Even now, there are objects that spark debate because they sit on the edge of what we can easily explain. Metallic spheres discovered in South Africa with their strange grooves etched around their middles. To geologists, they are natural formations, concretions born of slow chemical processes deep underground, and yet their near-perfect symmetry has led others to wonder if there might be more to them than simple geology. Most experts dismiss these claims, and perhaps rightly so, but the fascination lingers not because these specific objects are convincing, but because they force us to confront a larger question. If the Earth did contain the remnants of something that came before, would we even know what we were looking at? Our minds are trained to see the world in terms of the familiar. When we dig up fossils, we can recognize bones because we share them with the creatures they belong to. When we find pottery, tools, or ruins from ancient human cultures, we understand them because they look like things we might still use today. But what about a civilization that is not like us? One separated from us, not by culture or distance, but by tens of millions of years. Would its traces even look like artifacts, or would they look like ordinary stones? That is why the search for out-of-place artifacts, for all its controversies and dead ends, still carries a strange kind of weight. It forces us to admit how easy it would be for something to hide in plain sight, not because it is invisible, but because we have not yet learned how to see it. And perhaps one day we will. As our tools for studying the Earth grow sharper, we are beginning to see things in rocks that we could never have imagined before. We can read isotopic ratios in grains of dust. We can scan entire landscapes with satellites. We can drill deep into the seafloor and pull up samples that tell stories from epochs long before we existed. If there are artifacts that shouldn't exist, this is how we will find them. Not as polished relics pulled from the ground, but as tiny anomalies, as strange marks in data that force us to stop and wonder. Because maybe, just maybe, the first sign that we are not the first will not come from an object we can hold in our hands, but from a single quiet signal buried deep in the stone that tells us something once happened here that should not have been possible. And if we find that, it will not only change how we see the past, it will change how we see ourselves. When we imagine a civilization, we picture something large, towers against the sky, vast cities stretching to the horizon, roads, walls, and monuments that proclaim their builders' presence. But what if that image is only a reflection of us? What if intelligence does not have to be vast, and a civilization does not have to leave footprints we can see? Perhaps we have been looking in the wrong direction, up when we should be looking down. Life on Earth has never been simple. It has filled every niche, every possible size, every imaginable form. Some of its most successful designs have been the smallest. Bacteria ruled this planet for billions of years before anything with bones or shells even appeared. Even now, while we marvel at the complexity of our own minds, the world beneath our feet belongs to microbes. They outnumber us in every way. They live in places we cannot survive, in boiling vents at the bottom of the sea, in the frozen soil of Antarctica, and deep within the crust where no light has ever reached. We think of them as simple, but perhaps that is only because we do not yet understand them. They communicate, they organize, they share genes, passing information in ways that make our own learning seem slow by comparison. If intelligence can take many forms, could it not also take this one? A civilization not of giants but of the unseen. Imagine a world where thought itself is microscopic, distributed not in single minds but in vast interconnected networks, not cities of stone and metal but colonies in the soil, in the oceans beneath the surface, where time moves slowly and survival demands cooperation rather than conquest. If such a civilization ever existed, it would not have built monuments. It would not have carved its name into mountains or left roads across the land. Its traces would be chemical, biological, almost invisible. We might walk across its remains every day without knowing they are there. And if it vanished millions of years ago, what would be left? Perhaps a brief strange pulse in the fossil record, an anomaly in the chemistry of ancient sediments, a sudden bloom of compounds that do not appear naturally, nothing you could hold in your hands, nothing you would recognize at first glance, but it would be enough to hint that for a time something extraordinary happened, something that had nothing to do with us. It sounds impossible, but then again, so does much of life's history when you look at it closely. For most of the Earth's past, The dominant form of life was not the great reptiles of the Mesozoic or the towering forests of the Carboniferous, but microbes. Even now, if you measured the planet's living mass, they would outweigh us by an unimaginable margin. Intelligence, as we understand it, is new and rare. But life's persistence, that is ancient, that is everywhere. What if there was a form of intelligence that never needed to build in our way, that never needed fire or metal or language? What if its works were written not in stone, but in biochemistry, and then erased so thoroughly by time that the Earth has carried its memory only in the most subtle patterns? This is not to say that such a civilization did exist, but it does force us to rethink what we mean when we say civilization. We define it in our own image, but maybe we're only one example of a much larger possibility. And this, in its own way, is the heart of the mystery. Because if there is even the smallest chance that intelligence came before us in a form we do not recognize, then our search for it must change. We cannot just look for ruins and artifacts. We must look for the smallest traces, the kind that might be hiding in the deep rock or in the strange ancient chemistry of the planet itself. And perhaps we have already seen such traces without realizing what they were. Patterns in ancient rocks that do not match known geology, fossils of microbes that look oddly complex for their age, chemical shifts that cannot be fully explained. These things are not proof, but they are questions, and sometimes questions are more important than answers. If there were civilizations in miniature, they would not have been bound to the same fate as ours. They would not have been erased by crumbling cities or rusting machines. They would have been swallowed quietly by the earth, folded into its deep and patient memory, until nothing remained but faint hints waiting for someone curious enough to see them. And if that is true, then the planet beneath our feet might not just be old, it might be haunted, not by ghosts of our kind, but by the shadows of minds we will never meet, minds that thought in ways we cannot imagine, and left behind a record so small, so quiet, that it is almost invisible. And yet invisible is not the same as gone. If we are willing to imagine civilizations in miniature, then it's not such a leap to consider something even stranger, that the planet itself might be shaped not just by chance, but by the quiet work of life. For as long as there has been Earth, there have been engineers. Most of them are not like us. They do not build monuments, but they have reshaped this world in ways that no single species of our kind could ever hope to match. Think of the cyanobacteria, the ancient microbes that once thrived in the oceans more than 2 billion years ago. They were not intelligent in the way we are. They had no language, no cities, no tools, and yet they changed everything. Through photosynthesis they filled the air with oxygen, turning a suffocating atmosphere into one that could support complex life. Entirely by accident they rewrote the planet, and in doing so they made every living thing that came after, including us, possible. If we call ourselves builders, what do we call them? They may not have had plans or intentions, but their impact was greater than anything humans have achieved. In a sense, they were the first engineers, unconscious, unthinking, but powerful enough to reshape the world. And if such forces exist in the deep history of our planet, who is to say there could not have been others? Nature is full of quiet architects. Coral reefs, for example, are the work of tiny, simple creatures, yet their structures stretch for hundreds of miles. Vast living fortresses that can be seen from space. They're ecosystems, yes, but they're also constructions made layer upon layer across thousands of years. If they were to vanish and then be found by some future intelligence, might they not be mistaken for the ruins of some lost alien project? Now imagine taking that same principle and pushing it further. What if in the deep past there were forms of life that shaped the world so profoundly that we cannot even recognize their work for what it was? Not because it looked like anything we would build, but because it became part of the planet itself. A civilization of this kind would not leave behind tools or cities. Its legacy would not sit exposed on the surface. It would be geological. It would be folded into the crust as inseparable from the earth as the mountains or the seas. We might walk on it every day, never realizing that we are treading on the remnants of something that once was alive in a way we do not understand. There are already hints if you know where to look. Some scientists have suggested that certain massive geological formations, vast deposits of minerals or sudden shifts in global chemistry may have been driven not by blind physical processes, but by biology. The Great Oxidation Event triggered by cyanobacteria is one example. But what if there were others hidden deeper in time so far back that we cannot easily untangle cause from effect? What if some of the natural events we take for granted were, in a sense, the unintentional work of living things we no longer remember? This is not to say those life forms were intelligent in the sense we understand. They may not have had thoughts or plans. But then again, intelligence is not the only force that can change a planet. Sometimes persistence alone is enough. Billions of years of survival, billions of years of quiet interaction with the environment can leave marks just as lasting as any deliberate design. And here is where the idea grows even more unsettling. Because if nature has already reshaped this world through living things we can barely comprehend, what if one of those experiments went further? What if deep in the past a form of life arose that was not only persistent but purposeful? Life that did not just adapt to the Earth but altered it with intention. If such beings ever existed, their traces would not be obvious. They would not be artifacts in the way we think of them. They would be patterns. They would be strange alignments in the rock record, abrupt changes in the planet's chemistry, anomalies so subtle that we might mistake them for quirks of geology. And perhaps that is exactly what we're doing now. Perhaps the language of stones is already telling us these things, but we do not yet know how to translate it. This is why the idea of forgotten engineers of nature lingers. It is not about proving that something came before us. It is about realizing that life has been shaping this planet for so long, and with such immense power that we cannot easily separate its work from the work of the Earth itself. The two are entwined, bound together in a history far older than our species, older even than the creatures we think of as our distant ancestors. And if this is true, then maybe we're not the first to leave a mark. Not in the way we imagine, but in ways so deep and fundamental that they no longer look like the legacy of a civilization at all. They look like the planet. This is the real weight of deep time. It doesn't just erase, it absorbs. And in doing so, it may have hidden entire chapters of Earth's story within itself, leaving behind only the faintest hints that something once moved across this world with purpose. And so when we speak of forgotten engineers of nature, we're not only talking about what might have been, we're also talking about what is still here, hidden in the stones beneath our feet, in the chemistry of the oceans, and in the quiet record of a planet that has been alive for billions of years. Perhaps the question is not whether there were civilizations before us, but how many different ways there are for a world to remember its builders, and how many of those memories we have mistaken for nothing more than the ordinary bones of the Earth. If the Earth itself holds a memory written in stone, then perhaps we are not the only ones who have been listening for whispers of the past. Long before we had science, before we learned to read the language of rocks or drill into the ocean floor, humans told stories. Those stories were not written in data or measured in isotopes, but in myths, tales passed down through generations across cultures, shaped and reshaped until they became something more than simple history. For most of us, myths are entertainment now. Ancient legends of gods, floods, lost worlds, and forgotten ages feel like fiction, beautiful but detached from reality. Yet myths persist for a reason. They survive because they carry something people once thought was worth remembering. And while most of them are not literal, there is a curious possibility that buried somewhere within them might be fragments of memory, not of individual lives, but of events so vast and strange that they could only be preserved in story. Take, for example, the countless flood myths told across the world. In Mesopotamia, the Epic of Gilgamesh describes a great deluge that wiped away nearly everything. The Hebrew Bible tells of Noah. Ancient Hindu texts speak of Manu, warned by a fish of waters that would rise and cover the land. Even in the Americas and Oceania, cultures separated by oceans share their own versions of the same tale. To science, these stories are often seen as echoes of real but local events. Sea levels rose at the end of the last ice age. Massive floods carved entire valleys. Civilizations that lived close to the water would have experienced such disasters as the end of their world. Over time, those memories became myth. But here's the thing. Even if these myths are only exaggerated memories of natural events, they prove something remarkable. They show that memory, collective cultural memory, can last for thousands of years, reshaped into story, carried across time in the only way our ancestors knew how. Now, stretch that thought further. If memory can last that long in story, could it also stretch back further than we realize? Not in detail, not in facts and dates, but in strange symbolic fragments. If there was ever a time when humans, or even something before humans, encountered the fading traces of an older world, would it surprise us if the only place such an encounter survived was in myth? Consider the legends of lost civilizations. Atlantis is the most famous, a story told by Plato of a great city swallowed by the sea. To historians, it is a fable, a philosophical allegory rather than a literal memory. But why does it feel so familiar? Why does almost every culture seem to have its own version? A story of a lost age, a forgotten people, or a time when the world was different? From the Mayan Popol Vuh to the Hindu Yugas, from the Greek ages of man to the Norse tales of worlds rising and falling in endless cycles, the theme repeats. There were others before us, and the world has been remade many times. To us, they are myths. To those who first told them, perhaps they were only stories to explain the unexplainable. But there is another way to see them, not as literal history, but as instinct, a deep, unshakable feeling that our moment in time is not the first. Even if none of these myths are true in a literal sense, they reflect an older truth. The Earth has been here much longer than we have, and its memory stretches far beyond ours. For the people who first looked at fossilized bones protruding from a rock, who found seashells on mountain tops and petrified forests in stone, the world must have seemed haunted by its own past. They did not have geology to explain these things. They had myth. And perhaps myth was their way of hearing what the stones were saying, even if they could not translate the language. This is what makes these old stories strangely powerful. We dismiss them because we have science now, because we no longer need gods or legends to explain the shape of the Earth. But we forget that myth is often a way of holding on to questions that could not yet be answered. And those questions, the sense of something vast and forgotten, remain. What if buried inside those old tales there are faint echoes of real events so far removed from us that only story could preserve them? Not the literal memory of another civilization, but the shadow of the idea that the world has been reset before, that time is deeper than we can comprehend, and that we are only the latest in a long line of beginnings and endings. Even now, our own stories may one day become myths. Imagine what people, if there are still people, will say of us 10,000 years from now. They will not know our cities. They will not speak our languages. Perhaps they will only remember fragments, strange and distorted, transformed into symbols. If that can happen to us in so short a span, then how much has already been lost to time before we even arrived? This is why we should not dismiss myth entirely, because even if it does not give us answers, it reminds us of something that science alone cannot. That the human instinct to look backward is as old as our species itself. We have always known in some deep way that there is more behind us than we can see. And if that feeling exists, if it has followed us across every culture and every age, maybe it is because the Earth has always been whispering it, not in words, but in its sheer impossible age. Maybe myth is what happens when we hear that whisper, but do not yet know how to translate it. And perhaps one day, if we learn to read the stones well enough, we will find that the myths were not entirely wrong, not in their details, but in their quiet, unsettling suggestion that this world has had more than one story. If myth and memory hint at forgotten worlds, entropy explains why they vanish. Entropy is not a force we can see, but it is always at work. It is the quiet, unstoppable tendency of everything to move from order to disorder, from structure to ruin, until even the most enduring marks are smoothed away and scattered into nothing. You can see it in small ways every day. A building left alone begins to crumble. A road once straight and strong cracks as roots push through it. Metal rusts, stone erodes, wood rots. Given enough time, everything falls apart. We repair it for a while, but time always wins. This is entropy at the scale of a single human life. But on the scale of the Earth, it is far more ruthless. Imagine a city left to the world without us. Within decades, its lights would go out, its glass would shatter, and its steel would buckle. A few centuries later, the forests and grasslands would reclaim it. 1,000 years, and it would be hard to tell it was ever there. But 1,000,000 years, the city would be gone. The land would be bare again, reshaped by wind, rain, and stone. The ground would remember nothing of what once stood on it. This is what entropy does, not just to our works, but to everything. And when you extend it beyond human lifetimes, beyond even the rise and fall of species, you begin to see why the Earth has no permanent memory of its past. Every mountain you see is temporary. Every coastline will one day drown or rise. Every trace of us will be reduced to fragments, and then those fragments will be buried, broken, or transformed until they are no longer recognizable as anything but part of the planet itself. Even fossils, the most durable relics of life, are only partial survivors. They exist because of accidents, because an animal happened to be buried in the right sediment at the right moment and was spared from decay long enough for minerals to replace it. Most living things do not get such a fate. They vanish, their bones dissolve, their bodies leave no trace at all. If this is what happens to life itself, what chance does a civilization have? This is where oblivion comes in, not just the eraser of things, but their complete absorption into the larger processes of the Earth. Plate tectonics drags the crust downward, recycling it into molten rock. Erosion grinds the highest peaks into grains of sand. Entire oceans vanish and are reborn in different shapes. In deep time, the Earth is not a stage where history is preserved. It is a restless machine, always taking apart the old world to make room for the new. This is why the idea of a civilization older than us is not absurd. It is not that such a civilization would leave no trace because it never existed. It is that time and entropy would have taken those traces, scattered them, and folded them into the planet itself until nothing was left but a few chemical signatures we might mistake for natural events. And this is not just a thought experiment. We have already seen how effectively time erases. Consider the supercontinents. Hundreds of millions of years ago, the world's land masses were fused together into Pangaea. Before that there was Rodinia. Before that, Columbia. Each one rose, broke apart, and was reassembled into something new. The world has been rebuilt so many times that most of the surface rock from those ages has been destroyed or transformed. If a civilization had existed in one of those distant eras, its world would now be unrecognizable. Its continents would be gone, its oceans rearranged, its every trace buried under mountains or lost beneath the sea. It would not even be a ghost. It would be part of the bedrock. And yet, even in this vast erasure, there is something strangely beautiful, because entropy does not destroy everything entirely. It transforms, it takes what once was, and folds it into the greater whole of the planet. The stones we walk on may be the recycled remnants of mountains that stood before any animal walked on land. The minerals in those stones may once have been part of the oceans that dried up 1 billion years ago. In that sense, nothing is ever truly lost. It is only remade. One day, the same will happen to us. Our cities, our roads, our monuments, they will all be drawn back into the planet's long, slow cycle. And maybe in some far future, the atoms that once built our world will rise again as something new, unrecognizable, but still connected to us in ways that no one will ever see. This is what entropy teaches, that even the greatest works of life and time are temporary. Oblivion is not sudden, it is patient. It wears down everything until the past becomes indistinguishable from the stone beneath it. And if this is true, then maybe the most haunting part of the question isn't whether a civilization came before us. It's the realization that if it did, its end would have been so complete that it became part of the Earth itself. Not forgotten, not gone, just transformed until all that remained was the quiet fact that it had once been here at all. And perhaps if we look closely enough, we will find that we're already standing on its bones. If entropy and time erase almost everything, then what could possibly remain? The answer may lie in places stranger than stone or sediment. Some scientists suggest that the deepest record of the past may not be buried in the Earth at all, but written in the very fabric of reality, in the smallest particles, in patterns so subtle that we have only begun to imagine them. This is where the idea of what some have called a quantum fossil comes in. Not a fossil in the way we know it. No bones, no imprints in stone, but a trace of history encoded in the fundamental state of matter itself. It sounds impossible, almost like science fiction, and yet it may be one of the few ways in which the past could survive when every physical artifact is gone. To understand this, you have to think about how the universe keeps records. Every action, every event leaves a trail, even if it is so small that no one could ever measure it. When you drop a stone into a pond, ripples spread outward. They fade, yes, but in a perfect universe, those ripples would never truly disappear. They would keep going, their energy dissipating into smaller and smaller motions carried into the background noise of the world. Physics works in a similar way. At the quantum level, every interaction changes the state of the particles involved, even if only slightly. These changes cascade, branching outward, written into the vast interconnected web of reality. In theory, if you could rewind every particle in the universe, you could watch the past unfold exactly as it happened, not just for years or centuries, but for as long as time itself has existed. This is not something we can do. Of course, the information is too scattered, too deep in the noise. The second law of thermodynamics makes it practically impossible to gather it all back together. But the fact that it is there, that history in some form is never truly lost, changes the way we think about memory. And if that is true for every falling leaf, every drop of rain, and every gust of wind, then it must also be true for civilizations. Even if an ancient world left no ruins, no artifacts, and no chemical traces in the stone, some infinitesimal record of it would still ripple outward, written in the motion of atoms, in the scattering of photons, in the way matter itself rearranged as it passed through time. This is in many ways an abstract idea. You cannot hold a quantum fossil in your hand. You cannot dig it from the ground or lock it away in a museum. It is not something we could even detect with our current tools. But the concept serves as a reminder that nothing is ever erased entirely. The universe remembers everything, even if its memory is buried so deeply that it is functionally unreachable. For us, this means that the story of our world may be layered in ways we cannot see. The rocks give us one record, the oceans hold another, and beneath both of those, at the smallest scales, there may be an even deeper memory, one that will last until the last particle in the cosmos is quiet. If there was ever another civilization before us, this is where its last traces would be, in the most subtle changes of matter itself, perhaps in the alignment of molecules buried deep in ancient minerals, or in the slight inexplicable imbalances in systems we do not yet know how to measure. It is a kind of history that does not speak, but hums quietly at the edge of what is possible to know. And this leads to a humbling realization. If we are not the first, then nothing we do can ever fully erase those who came before. They are not gone in an absolute sense. They are hidden in the same way that an old melody is hidden in the vibrations of a string after the sound has faded. Still there, still resonating, but far too faint for our ears. One day, our own world will be reduced to that same state. Our cities will be dust, our oceans will change, even the continents themselves will be ground down and rebuilt. But at the smallest scales, the memory of our existence will remain, scattered into the infinite background of reality, waiting for no one and belonging to nothing. We may never touch this memory, we may never read it, but it is there, and perhaps that is enough, because it means that nothing, no world, no species, no brief flash of civilization is ever entirely erased. And if the universe can hold on to something so small for so long, then maybe, just maybe, that is why the idea of forgotten ages is so hard for us to let go. We feel it, because the world itself has never completely lost it. We live, we fade, and we become part of the quiet hum of history. And one day we too will be quantum fossils folded into the deepest memory of the cosmos, joining whatever other voices are already there, whether we ever learn their names or not. If the universe remembers everything, then what will it remember of us? One day, long after our cities have vanished and our language has been forgotten, what will be left for the archaeologists of the far future, if there is anyone left to dig through the dust we leave behind? To answer that, we have to begin by admitting something uncomfortable. For all our power, for all our technology, and all our ambition, we are astonishingly temporary. The things we build are fragile. Even the strongest of them cannot outlast the slow patience of the earth. Bridges collapse, roads fracture, towers rust and crumble. We patch them, repair them, rebuild them, but in the absence of hands to keep them standing, they will fall. If we vanished tomorrow, nature would begin its quiet work almost immediately. Within a few years, vines would climb the walls of our tallest buildings. Within decades, forests would spread over highways, and rivers would carve new paths through what were once neighborhoods. Within a few centuries, even the most imposing of our monuments would be reduced to rubble. But in the deep future, thousands, millions, or even tens of millions of years from now. The very ground would take them, the foundations would sink, the rubble would be buried beneath layers of sediment, and in time those layers would turn to stone, and the last visible traces of us would vanish. This is what the archaeologists of tomorrow would face. They would not be sifting through our ruins, they would be sifting through the earth itself, and what they would find would not look like the world we know. They would not see cities, they would see a strange layer in the rock. That layer would not be thick, a few centimeters perhaps across the entire planet, but within it would be a record of everything we are. The metals we mine and spread across the world, the plastics that even as they break down will leave behind stubborn little traces, the isotopic scars of our fuel-burning age, locked into stone the way the iridium layer marks the death of the dinosaurs. In that thin band of rock, the archaeologists of tomorrow could read our story. They might not know the details, but they would know this. For a brief moment in the deep history of the Earth, something happened, something strange and powerful enough to change the chemistry of the planet itself. It is humbling to think that this will be our legacy, not the monuments we build, not the words we write, but a thin layer of altered stone, and yet, in a way, it is fitting, because this is how the Earth remembers. If we imagine those future archaeologists, we cannot help but wonder who they will be. Perhaps they will be our descendants far removed from us, living in a world we would not recognize. Perhaps they will not be human at all. Evolution is patient, and it does not stop simply because we are here. Given enough time, it could shape intelligence into forms entirely unlike our own. Or maybe those archaeologists will come from elsewhere. Beings who arrive on a world long emptied of life and sift through the quiet layers of its past, just as we now dig through the fossils of vanished ages. They will find our layer and know for the first time that this world was once alive in a way they can scarcely imagine. What would they make of us? Would they see the metals and plastics and assume they were the byproducts of some natural catastrophe? Or would they recognize them for what they are, the traces of a civilization that rose, changed its planet, and disappeared? If they are anything like us, they will wonder. They will try to read meaning into the record, to see patterns in the noise. They will ask the same question we're asking now. Were we the first, or are we only the most recent? In a way, we're already their archaeologists. We drill into the deep past, unearthing strange signals and faint memories of worlds that ended long before we were born. We stare at those traces and try to make sense of them. And sometimes, just sometimes, we wonder if we're not only looking backward, but also forward at the kind of evidence we ourselves will one day leave behind. This is what the archaeology of tomorrow really is. A mirror. It shows us the future, but it also shows us the truth about the present. We are not as permanent as we think. We are a brief layer in the stone, here for a moment and then gone. Our story reduced to its simplest, most durable form, a chemical fingerprint, a whisper of what once was. And maybe that is enough, because even if no one comes to read that layer, even if the future belongs to silence, we will still be part of the Earth's memory. We will join the long history of everything that has ever lived and died here. Our chapter folded into the bedrock, just like all the others. And if someone does come, if they split open the stones and find our ghost there, perhaps they will feel the same thing we feel now when we look at the ancient past, a quiet, humbling wonder. Because that is what deep time does. It erases, but it also connects. It binds every world, every species, and every brief civilization into the same vast story. A story written not in words but in the slow, unbroken language of the Earth itself. When you step back far enough, the Earth itself begins to look small. Its history feels impossibly vast to us, yet, in the context of the universe, it is only a moment, a brief spark in an endless darkness. And it is in that darkness that the question of forgotten civilizations takes on an even stranger shape. Because if this world could have erased every trace of anything that came before us, then what about the others? There are hundreds of billions of stars in our galaxy alone. Many of them have planets. Some of those planets may have oceans and atmospheres, the basic ingredients of life. And if life can appear here on one unremarkable world circling an ordinary star, why not there? Why not everywhere? This is where the cosmic perspective changes everything. We spend so much time wondering whether we're alone, whether there is anyone else out there. But perhaps the better question is whether anyone who was ever out there is still around to be found. Because if deep time erases nearly everything here, then the same must be true everywhere else. Imagine a civilization that arose 1 billion years ago on a world circling a distant sun. They might have built wonders, they might have crossed their skies and written their names into the very crust of their planet. But what would be left of them now? Even if their world is still there, their traces would be gone. Their cities would be dust, their monuments buried, their works ground into the stone till no one could ever know they existed. This is what makes the silence of the cosmos feel different when you think of it this way. Perhaps we do not hear other civilizations, not because they were never there, but because they too were erased. Perhaps intelligence is not a rare spark, but a repeating one. A brief flare that burns, changes its world and fades, leaving behind nothing but a thin chemical shadow and the faintest whisper in the rocks. And if that is true, then we are not only part of Earth's story, we are part of the universe's story. One more brief chapter in a book that may have been written many times before on many worlds in many ways. We may never see those other chapters. The distance between stars is too great, and time is a far more merciless barrier than space. Even if we could cross the galaxy, we might find only planets that once lived but live no longer. Yet there is a strange comfort in this, because it means that we are not alone, not in the way we usually think. We may never meet the others, but we are walking paths that may have been walked before. Every choice we make, every mark we leave, ties us to a pattern as old as the stars themselves. It also forces us to see our own world in a new way. If planets are graveyards of forgotten civilizations, then Earth is not unique in its silence. It is simply one of countless worlds carrying its past deep within it, hidden under layers of time. And one day, if we endure long enough, we may go to those other worlds. We may drill their rocks and study their sediments the same way we study our own, and perhaps, just perhaps, we will find something, an anomaly in the chemistry, a trace that does not fit, a thin, stubborn layer that tells us we are not the first. The thought is almost too large to hold, but then again, so is the universe. And this is the real power of the cosmic perspective. It reminds us that the story of forgotten civilizations is not just about our planet, it is about everything. Every world with oceans, every world with mountains and skies, every world that has ever had enough time for life to rise, change its home, and vanish. If the universe truly keeps its memory, then it is written not only in the stones of the earth, but in the dust of 1,000 other planets. And if we learn how to read it, we may one day discover that we are part of something far greater than a single isolated story. Because in the end, the cosmos does not care about beginnings or endings. It only carries on, indifferent and infinite, holding within it every trace of everything that has ever been. And somewhere in that immensity, perhaps our own layer, the thin chemical line that will one day be all that is left of us, will be only one among many, a single page in a library without end. And if that is true, then the silence above us is not empty at all. It is full of everything that has ever been lost, everything that has ever lived, everything that has ever wondered if it was alone. And now it is our turn to wonder. If they were here before us, we would not see them. That is the hardest truth to accept. We like to imagine that the past leaves bold and undeniable traces, but deep time does not work that way. It is patient, and in its patience it erases almost everything. If another civilization walked this planet millions of years before we did, we would not find their cities. The towers would have fallen, the streets would have crumbled, even their bones would be gone. In their place there would be forests, deserts, oceans, mountains, a new world layered over the old until nothing remained of what came before but silence. And yet, not all silence is empty. If they were here, their traces would be hidden in places we do not usually think to look. Not in ruins or monuments, but in the deep, quiet record of the earth. Their world would survive only as patterns, a sudden unexplained chemical shift in the rocks, an odd concentration of metals in a layer of ancient soil, molecules that do not appear in nature, trapped in sediments buried miles underground. To us, those things might look like geological curiosities. We might chalk them up to unusual volcanic activity, or the strange chemistry of ancient oceans and move on. And perhaps we already have. This is the unsettling part. We may have walked past their fingerprints without ever realizing what they were. A sample pulled from the ground, measured, catalogued and filed away. Its oddities written off as natural noise. How many strange results have been quietly noted in scientific papers, explained in footnotes, and then forgotten? How many of them might be the faint final echoes of something that came before us? If they were here, they would be ghosts now. Not the kind that haunt the edges of our vision, but the kind that haunt the data, numbers that don't quite add up, signals that don't quite match what we expect. Ghosts not of stories, but of physics and chemistry, imprinted into the bones of the world. And even if we found such a ghost, would we recognize it? That is the other challenge. We are so used to thinking of civilization in human terms, cities, tools, fire, and language, that we might not see another kind of intelligence, even if its remains were sitting right in front of us. What if they did not build as we do? What if their technology was not metal and stone, but something that left no obvious scars? What if their impact on the planet was so subtle that in our terms it would look like nothing at all? Even we are already learning how to vanish in this way. Our technology is shifting toward the invisible, circuits no wider than a hair, materials designed to break down, to leave no waste behind. One day our own mark on this planet may be almost impossible to detect. If we can imagine a future where we disappear cleanly, why not a past where someone else already did? And perhaps in a way that is the only way it could be. If intelligence can arise more than once, then it must also vanish more than once. And every time it does, the Earth will do what it always does. Bury it, erase it, and leave behind nothing but a faint chemical memory deep in the rock. If they were here before us, they are not waiting to be found in the sand or the stone, as cities or machines. They are waiting in the quiet. They're waiting in the data. And maybe one day, when we are patient enough, careful enough, and humble enough to look for something that is not built in our image, we will finally hear them, not in words, not in artifacts, but in the quiet truth the Earth has been holding for millions of years, that we were not the first. And if that day comes, it will not make us smaller, it will not make us less, it will connect us to something larger than we can imagine, a chain of worlds and minds that stretches deep into time, a story that has been told and erased and told again long before we ever learned to wonder about it. And when we see ourselves as only the latest part of that story, perhaps we will finally understand the real scale of what it means to live on a world this old. Because if they were here before us, then one day we too will be the ones who came before, and someone else will walk the earth and wonder. If you listen closely enough, there is a kind of silence in the world that feels heavier than the rest. Not the silence of an empty room or a quiet night, but the silence of deep time. It is the silence of everything that has ever been folded into the earth, erased from sight but not from existence. It is a silence that holds weight because it is not empty, it is full. We walk across it every day without noticing. Every stone beneath our feet is a fragment of the past. Every layer of soil carries the dust of worlds that no longer exist. Even the air, shaped by ancient life and its long-forgotten transformations, is a kind of ghost, a reminder that our present is built on the ruins of 1,000 vanished ages. When we imagine ourselves as the first, we do so because we can only see the surface. But the surface is thin. Beneath it is a planet that has been writing and erasing its history for 4.6 billion years. And in all of that time, is it really so hard to imagine that others might have come and gone before us? If they were here, we will not find their streets, we will not find their faces, but maybe we will find something smaller and quieter, a chemical fingerprint, a pattern in the rocks, an anomaly in the deep ocean mud that refuses to be explained away, a whisper, not a shout. And if we are listening carefully enough, that whisper may be all we need, because in the end, that is what deep time gives us. Not certainty, but possibility. The Earth is vast enough to erase everything except the smallest traces, and yet those traces still matter. They tell us that nothing we see is permanent. They remind us that our own chapter will be no different. One day, millions of years from now, the cities we know will be gone, the continents will have moved, new mountains will have risen and been worn away again. And if someone, human or not, were to look for us, they would not find our world, they would find a layer in the stone, a faint chemical echo of our presence. That is all we will be. And yet there is something strangely beautiful in that thought, because it means we will join everything else. We will become part of the same silent record that holds the oceans that have come and gone, the forests that turned to coal, the creatures that ruled the earth and then vanished without a sound. We will be another echo in the dark, and if there were others before us, they are there too, folded into the same silence, waiting not to be discovered in the way we normally think of discovery, but simply to be noticed. Not proof, not certainty, just the quiet recognition that time is not ours alone. This in the end is what humbles us, not the scale of the universe, but the scale of our own world. We live in its newest layer, thin as dust, perched on top of an age so deep we can barely measure it. We tell ourselves we know it, but we have only brushed its surface. And maybe that is the point. Maybe we are not meant to find every answer. Maybe we're only meant to keep asking, to keep looking down into the earth and feeling the weight of what it hides until the silence stops feeling empty and starts to feel alive. Because when you stand in that silence, when you look at the rocks, the oceans, the stars, you begin to hear it. A faint hum, a low and endless echo. It does not give names. It does not tell stories. It only reminds you that time is long, the earth is patient, and that if we were not the first, then one day we will not be the last. And maybe that is enough, because in that echo there is no ending, only the quiet, unbroken rhythm of a world that has carried countless beginnings and will carry countless more long after ours has turned to dust. The earth will keep turning, the stones will keep their silence, and somewhere hidden deep in the dark, every story that ever was, ours included, will still be there, folded into the memory of the planet, waiting. And if you listen closely enough, you can almost hear it. Tonight we have travelled together through deep time, from the newest layer of earth where we build our cities, down through millions of years of stone and silence. We have asked a question that has no easy answer. Were we the first? In the deserts we found silence that preserves. In the oceans an archive deeper than any library. In the language of stones we discovered that the earth speaks in chemistry rather than words. We learnt about the Silurian hypothesis, not as proof of ancient civilizations, but as a humbling reminder that our methods of reading the past are still incomplete. We imagined fossils of fire and steel, the chemical ghosts that we ourselves are already creating. We considered civilizations in miniature, intelligence that might have worked in ways we cannot recognize. We explored how the earth erases almost everything, how entropy reduces even the greatest works to dust, and how time runs backward to show us that nothing we see is permanent. From myth to quantum fossils, from the archaeology of tomorrow to the cosmic perspective, we have seen that the question of forgotten civilizations is not really about them. It is about us. It is about time itself. It is about recognizing that we live on a planet so old that our entire story is written in its thinnest layer. Whether there were others before us, we may never know for certain. The earth is vast, and we have only just begun to learn how to read its deepest memories. But the question itself changes us. It reminds us that we are not permanent, that our time here is brief, and that the ground beneath our feet holds secrets we are only beginning to imagine. If there were civilizations before us, they too faced the same choice we face now. How to live knowing that time erases everything. How to build knowing that nothing lasts. How to hope knowing that one day we too will be nothing but a whisper in the stones. And perhaps that is the real answer. Not whether we are the first, but how we choose to live with the question. Because in the end, the earth does not care about our monuments or our cities. It only remembers what we leave in its bones, the chemicals we release, the elements we scatter, the thin layer of difference we press into the rock. That will be our fossil. That will be our ghost. But maybe, just maybe, that is enough. Because even if the earth forgets our names and our stories, it will remember that we were here. We will join the long record of everything that has ever lived and thought and wondered on this ancient world. And if someone comes after us, if they drill deep into the stone and find our layer there, perhaps they will feel what we feel now when we look at the deep past, a quiet wonder, a humbling recognition that time is larger than any single story. And they too will ask the question that echoes through every age, were we the first? The earth will not answer directly. It will only whisper in its slow language of stone and chemistry. But the whisper will be enough, because it carries within it the truth that connects all worlds, all species, all brief moments of consciousness that arise and fade in the vastness of time. We are not alone in asking this question. Every mind that has ever wondered about its place in time has asked it in its own way, and the question itself becomes the answer. Because to wonder if we are the first is to recognize that we are part of something larger than ourselves, something that began long before us and will continue long after we are gone. The stones remember, the oceans keep their archives, the quantum foam holds every trace of everything that ever was, and somewhere in that vast memory, every civilization that ever wondered about its place in time is still there, still asking the same eternal question. Were we the first? The answer echoes through deep time. You are not alone. You are never alone. You are part of the story, and the story never ends. There is something profound about holding a piece of ancient stone. When you press it against your palm, you are touching time itself. That rock might be older than complex life on Earth. It might have been there when the first cells learned to breathe oxygen, when the first forests grew, when the first creatures crawled from the sea. And in that moment you become part of a chain that stretches back through unimaginable ages. Your hand connects to stone that witnessed events no human eye ever saw. It watched the world change in ways we can barely comprehend. But what if that stone watched something else? What if, in its billions of years of patient existence, it was present when intelligence first awakened on this planet? Not our intelligence, but something older, something that came and went so long ago that only the rocks remember? This is where the question becomes more than academic. It becomes personal. Because if the Earth has hosted other minds, other ways of thinking and building and wondering, then the very ground we walk on becomes a graveyard of dreams. Every mountain, every valley, every stretch of desert could be built on the remnants of worlds we will never know. The rocks don't speak to us in words, but they speak nonetheless. In their layers we read the history of ice ages and warm periods, of asteroid impacts and volcanic catastrophes, of mass extinctions and the slow recovery of life. Each layer is a page in the longest book ever written, and we are only just learning to read it. But what if some of those pages contain stories we don't recognize? What if scattered through the geological record are traces so subtle, so transformed by time, that we walk past them every day without realizing what they are? Consider the Precambrian, that vast stretch of time before complex life left clear fossils. It represents more than 80% of Earth's history. Billions of years when the planet was supposedly empty of anything we would recognize as intelligent. But was it truly empty? Or does our definition of intelligence blind us to forms of awareness that might have existed in ways we cannot imagine? The Precambrian rocks hold secrets we are only beginning to unlock. Strange formations that don't quite fit with our understanding of how early Earth should have looked. Chemical signatures that suggest biological processes we can't fully explain. Patterns in the stone that look almost purposeful, almost designed, but which we dismiss as the random work of geology. What if they are not random at all? What if they are the last whispers of minds that thought in geological time, that worked not in decades or centuries, but across millions of years? Forms of intelligence so different from ours that we cannot even conceive of them, let alone recognize their remains? This brings us to a humbling realization. We define intelligence in our own terms. We look for cities because we build cities. We look for tools because we use tools. We look for language because we speak. But intelligence might express itself in ways that have nothing to do with any of those things. What if intelligence manifested as the ability to guide evolution itself? What if there were forms of awareness that worked not by building external structures, but by shaping life from within, directing the flow of genes, guiding the development of new species, orchestrating the dance of biology across millions of years? Such intelligence would leave no cities, no monuments, no artifacts we could recognize. Its only trace would be in the fossil record itself, in patterns of evolution that seem too purposeful, too directed to be entirely the work of chance. And who would notice? Who would think to look for consciousness in the shape of a shell or the structure of a long-extinct organism? We have already seen hints of this kind of deep influence. The Cambrian explosion, when complex life suddenly diversified into countless new forms, happened with a speed that puzzles scientists. Was it purely the result of environmental changes and evolutionary pressure, or was something else at work? something that guided and shaped the explosion of life into new and more complex forms. The question sounds like science fiction, but it emerges from the simple recognition that consciousness might not be limited to the narrow band of possibility that includes human-like minds. If awareness can arise once, it can arise in countless different ways, and some of those ways might be so alien to us that we would never recognize them, even if their influence shaped the very world we live in. This leads to an even stranger thought. What if consciousness is not an accident, but an inevitable result of complexity? What if the universe itself tends toward awareness, and Earth has been a laboratory for consciousness far longer than we imagine? In this view, we are not the first awakening of mind on this planet, but only the latest in a long series of experiments in awareness. Each form of consciousness that arose left its mark, not in metal and stone, but in the development of life itself. Each guided evolution in its own direction, explored its own possibilities, and then passed away, leaving the stage set for the next act in the drama of mind. If this is true, then we are not alone in the way we usually think. We are not isolated sparks of consciousness in a dead universe. We are part of a lineage of awareness that stretches back through geological time, each generation building on the work of those who came before, each adding its own chapter to the story of mind on Earth. But where does that leave us? If we are only the latest in a long line of conscious beings, what does that mean for our future? Are we destined to follow the same path as those who came before, to rise and flourish and then fade away, leaving only subtle traces for whatever comes next? Perhaps, but perhaps not. Because unlike those earlier forms of consciousness, we have something unique. We have memory. We have the ability to look back through time and recognize the possibility that others came before us. We can learn from the deep past in ways that no previous form of consciousness could. This gives us a responsibility as profound as it is daunting. If we are the first form of consciousness capable of remembering the deep past, then we are also the first capable of preserving it. We are the first who might be able to break the cycle of rise and forgetting that has dominated the history of mind on Earth. But that preservation cannot happen through monuments or cities. Those will crumble like everything else. It can only happen through understanding, through learning to read the language of stones so well that we can hear the whispers of every form of consciousness that ever shaped this world. And perhaps if we listen carefully enough, we might hear something more. Perhaps the rocks themselves might tell us not just what happened, but why. What drove each form of consciousness to rise and flourish? What caused them to fade? And what can we learn from their stories to write a different ending for our own? The stones are patient. They have waited billions of years to tell their stories. The question is whether we are ready to listen. In the deep archives of the Earth, there are librarians who have been keeping records since the beginning of time. They are not human, not conscious in any way we would recognize, but they are faithful beyond measure. They are the crystals, the sediments, the slow-growing formations of mineral and stone that preserve in their structure the memory of everything they have witnessed. These keepers of memory work in ways we are only beginning to understand. A single crystal can hold within its lattice the chemical signature of the water from which it formed. That water might have fallen as rain millions of years ago, carrying in its composition the exact state of the atmosphere at that moment. When we study the crystal today, we are reading a message from a world long vanished. Sedimentary rocks work as archivists on an even grander scale. Each grain of sand, each flake of clay, each tiny fragment that settles to the bottom of an ancient ocean carries information. Where it came from, what kind of rock it weathered away from, what the climate was like when it made its journey. Layer by layer, year by year, these sediments build up into vast libraries of stone. But what makes these natural archivists truly remarkable is their indifference. They record everything equally. The rain that falls on a pristine landscape and the rain that falls on a polluted city leave different chemical signatures, but the sediments preserve both with equal fidelity. They don't judge, they don't edit, they don't decide what is important and what can be forgotten. They simply keep track of everything. This means that if there was ever a civilization before us, the memory keepers would have recorded it. Not intentionally, not because they cared about preserving the story of another species, but because recording is what they do. They would have captured the chemical changes, the altered erosion patterns, the strange new compounds that an industrial civilization inevitably produces. The question is not whether the record exists. The question is whether we can learn to read it. Consider what we have already learned to see in the stone archives. We can read the history of Earth's magnetic field in the orientation of tiny iron crystals formed at the bottom of ancient seas. We can track the movement of continents by studying the age and composition of rocks on different sides of the ocean. We can see the fingerprints of ancient volcanoes in ash layers scattered across multiple continents. Each of these discoveries required us to develop new ways of looking, new techniques for extracting information from stone. And each time we learn to see something new in the rocks, we find that the record was always there, waiting for us to become sophisticated enough to read it. The same would be true for the traces of an ancient civilization. The signals would be there, preserved in the faithful archives of stone and sediment, but they would be written in a language we have not yet learned to speak. What would that language look like? It would be the language of chemistry and physics, of isotopes and trace elements, of subtle patterns that repeat across vast scales of space and time. It would be a language without words, but with perfect grammar, a language that could tell us not just that something happened, but when it happened, how long it lasted, and what kind of processes were involved. Learning to read this language would require more than just better instruments. Though those would certainly help, it would require a fundamental shift in how we think about the past. We would need to stop looking for the kinds of evidence that civilizations like ours might leave, and start looking for evidence of any kind of systematic change in the environment. This shift in perspective might reveal patterns we have never noticed before, subtle correlations between different types of geological formations, chemical signatures that appear in rocks from the same period but different locations, traces of processes that don't quite match anything in our current understanding of how Earth systems work. Each of these anomalies might be nothing more than natural variation, the result of geological processes we don't fully understand, but taken together, they might tell a different story. They might be the scattered chapters of a book written in stone, waiting for someone with the patience and skill to piece them together. The memory keepers have been at work for billions of years. In all that time, they have never failed in their duty. Every event that has ever affected the chemical composition of air or water, every process that has ever altered the flow of sediments from land to sea, every phenomenon that has ever left a trace in the physical world has been faithfully recorded. If there were other forms of consciousness on Earth before us, if there were other ways of organizing matter and energy into purposeful activity, the memory keepers would have taken note. They would have recorded the changes, preserved the evidence, and kept it safe until someone came along who knew how to ask the right questions. We are beginning to learn how to ask those questions. We are developing the tools and techniques needed to read the deepest archives of the Earth. And as we do, we may find that the planet has been keeping secrets far stranger and more wonderful than we ever imagined. But reading the archives is only the first step. Understanding what they tell us is another challenge entirely, because the memory keepers record everything, but they explain nothing. They preserve the what and the when, but not the why. They can tell us that something unusual happened 50 million years ago, but they cannot tell us whether that something was the work of consciousness or mere chance. That interpretation must come from us. We must learn to see patterns in the data, to distinguish between the signals of purpose and the noise of natural variation. We must develop new theories, new frameworks for understanding what kinds of processes could leave the kinds of traces we might find. And perhaps most challenging of all, we must remain open to the possibility that consciousness in the deep past might have worked in ways so different from our own that its traces would be almost unrecognizable. The memory keepers are faithful, but they are not translators. They preserve the record, but they do not make it easy to understand. Still, they are there, waiting in the deep places of the Earth. The crystals and sediments, the layers of stone and beds of ancient clay, the memory keepers of a planet that has witnessed more than we can imagine, and forgotten less than we might think. All we have to do is learn to listen to what they have been trying to tell us all along. There is a cruel arithmetic at work in the deep history of Earth, a mathematics of disappearance that governs what survives and what is lost to time. Understanding this arithmetic is crucial if we want to grasp why finding evidence of ancient civilizations is not just difficult, but approaches the mathematically impossible. Consider the numbers. Earth is approximately 4.6 billion years old. Human civilization, in the sense of organized agriculture and cities, is perhaps 10,000 years old. Industrial civilization, the kind that might leave detectable traces, is less than 300 years old. The ratio is staggering. If Earth's history were compressed into a single year, industrial civilization would occupy less than the final second. But the arithmetic becomes even more brutal when we consider preservation. Of all the living things that have ever existed on Earth, what fraction have left fossils? Paleontologists estimate that far less than 1% of all species that ever lived are represented in the fossil record, and that's for organisms with hard parts, bones, shells, exoskeletons, that have some chance of preservation. For soft-bodied organisms, the preservation rate drops to nearly zero. For behavior, for culture, for the ephemeral products of intelligence that don't involve hard materials, the preservation rate is essentially zero. We know almost nothing about the behavior of extinct species beyond what we can infer from their preserved hard parts. Now apply this mathematics to civilization. What fraction of human civilization would be recognizable after 1,000,000 years? After 10 million? After 50 million? The steel rusts away, the concrete crumbles, the plastics break down into molecular fragments. Even the most durable artifacts eventually succumb to weathering, erosion, and the slow recycling of the Earth's crust. But let's be generous. Let's assume that some tiny fraction of a civilization's traces might survive for geological timescales. Perhaps 1 part in a trillion of its material culture, scattered and transformed, but still detectable to sufficiently advanced instruments. Even then, the mathematics work against discovery. Consider the sampling problem. We have examined in detail perhaps 1 part in 1,000,000 of Earth's surface rocks. We have drilled core samples from a tiny fraction of the ocean floor. We have studied in depth perhaps 1 layer in 1,000 of the available sedimentary record. If the traces of an ancient civilization exist at all, they are scattered among billions of cubic kilometers of rock that we have never examined and may never be able to examine. It's like looking for a single sentence in a library containing every book ever written, when you're only allowed to read 1 page from 1 book every few years. The sentence might be there, but finding it would require either extraordinary luck or a search strategy so sophisticated that we haven't invented it yet. This sampling problem is compounded by what mathematicians call the detection threshold. Not every trace that survives is detectable with current instruments. The chemical signature of an ancient civilization might be present in the rocks, but if it's below our detection threshold, we'll never know it's there. And our detection thresholds, while improving, are still crude compared to the subtlety of the signals we might be looking for. There's also the recognition problem. Even if we detect an anomaly, how do we know it represents evidence of intelligence rather than an unknown natural process? The Earth has been experimenting with chemistry and physics for billions of years, producing effects that still surprise us. Distinguishing between the signatures of intelligence and the signatures of exotic geological processes requires not just detection, but understanding. And our understanding of what intelligence might look like after millions of years of transformation is necessarily limited. The mathematics become even more sobering when we consider timescales. Human industrial civilization has existed for roughly 200 years. If an alien civilization had an equivalent industrial period before vanishing, and if such civilizations arose randomly throughout Earth's history, how many would we expect? Let's be optimistic and assume that intelligent life arises every 100 million years, and that each such civilization lasts for 1,000 years before either disappearing or transcending to forms that leave no detectable traces. Over Earth's 4.6 billion year history, that would give us perhaps 46 opportunities for intelligence to arise. But here's where the mathematics turn truly stark. Of those 46 civilizations, how many would have left traces detectable today? Given the preservation rates we discussed, given the sampling problems, given the detection and recognition thresholds, the answer might well be zero. Even if ancient civilizations existed, the mathematics of disappearance suggest we might never find them. This is not a cause for despair, but for perspective. The absence of evidence for ancient civilizations is not evidence of their absence. It is exactly what we would expect given the mathematics of preservation and discovery on a planet that recycles its surface every few 100 million years. But the mathematics also point toward hope. As our instruments become more sensitive, as our sampling becomes more comprehensive, as our understanding of both geology and intelligence deepens, we approach new thresholds. We may soon be able to detect signals that were invisible to previous generations of scientists. The mathematics of disappearance are brutal, but they are not absolute. Information can survive in unexpected places, encoded in unexpected ways. A single volcanic ash layer can preserve the chemistry of an ancient atmosphere. A single crystal can hold the magnetic signature of a moment billions of years ago. A single grain of shocked quartz can testify to an asteroid impact that happened before complex life existed. If the traces of ancient intelligence exist, they exist in these kinds of unexpected places, encoded in ways we are only beginning to understand. Finding them will require not just better instruments, but better mathematics, new ways of analyzing data, new methods for detecting patterns, new approaches to the fundamental problem of extracting signal from noise. The mathematics of disappearance tell us that we are looking for something almost impossibly rare and difficult to detect. But mathematics also tell us that almost impossible is not the same as impossible. And for a question this profound, even the slimmest of chances might be worth pursuing. Because in the end, the mathematics work both ways. If it's almost mathematically impossible for ancient civilizations to leave detectable traces, it's also almost mathematically impossible for us to be the first intelligence ever to arise on this ancient planet. Somewhere in those vast odds, in that cruel arithmetic of time and preservation, there might be room for the most extraordinary discovery in human history. The numbers are daunting, but they are not decisive. And as long as that's true, the search continues. In the deepest archives of scientific data, buried among thousands of measurements that conform to our expectations, there are always outliers, strange readings that don't quite fit, anomalies that stick out from the pattern like notes played out of tune in an otherwise harmonious symphony. Most of these outliers are exactly what they appear to be: errors, contamination, equipment malfunction, or simply the random variation that characterizes any real-world measurement. Scientists learn to expect them, to filter them out, to focus on the signal rather than the noise. But what if some of that noise is not noise at all? What if scattered through decades of geological and geochemical data are signals we have dismissed because we didn't know what we were looking for? Consider the Oklo natural nuclear reactors in Gabon, Africa. These formations, discovered in the 1970s, preserve evidence of natural nuclear fission that occurred 1.7 billion years ago. When they were first discovered, the isotopic signatures looked so artificial that scientists initially suspected contamination from modern nuclear facilities. The ratios of uranium isotopes were all wrong for natural uranium, depleted in exactly the way that uranium becomes depleted in human-made nuclear reactors. It took years of careful investigation to establish that these were indeed natural phenomena, created by a remarkable convergence of geological circumstances that allowed self-sustaining nuclear reactions to occur in ancient uranium deposits. But for a brief moment, scientists faced the possibility that they had found evidence of nuclear technology operating billions of years before humans existed. The Oklo discovery illustrates both the promise and the challenge of searching for ancient technological signals. The promise is that such signals, if they exist, can be preserved in the geological record for billions of years. The challenge is distinguishing them from natural processes we don't yet understand. This challenge is particularly acute because nature has had billions of years to experiment with chemistry and physics. Many processes that we might initially think require intelligence or technology can, it turns out, be produced by purely geological means. Natural selection, given enough time, can create structures and systems of remarkable sophistication without any conscious direction. But the challenge cuts both ways. Just as we might mistake natural processes for technological ones, we might also mistake technological signatures for natural ones. If an ancient civilization used technologies based on principles we don't understand, or if they worked with materials and energy sources we haven't discovered, their signatures might be invisible to us not because they don't exist, but because we don't know what to look for. This is where the systematic analysis of outliers becomes crucial. Instead of dismissing anomalous readings, we need to collect them, catalogue them, and look for patterns. Do certain types of anomalies cluster in particular geological formations? Do they correlate with specific time periods? Do they show geographic distributions that suggest systematic rather than random causes? Such pattern analysis has already yielded surprising insights in other fields. In astronomy, the systematic study of anomalous stellar spectra led to the discovery of dark matter. In particle physics, the investigation of unexpected particle collision results revealed new fundamental particles. In genetics, The study of anomalous inheritance patterns uncovered mechanisms of gene regulation that transformed our understanding of evolution. The same approach could be applied to the geological record. We need databases that catalogue not just the expected results, but the unexpected ones. We need algorithms that can detect subtle correlations across vast datasets. We need new statistical methods that can distinguish between truly random anomalies and those that show the faint signatures of underlying patterns. Some of this work is already beginning. The rise of big data analytics and machine learning is giving scientists new tools for pattern recognition in complex datasets. Artificial intelligence systems can now detect subtle correlations that would be invisible to human analysis, finding needles in haystacks too vast for any individual researcher to examine. But these tools also raise new challenges. How do we distinguish between meaningful patterns and the spurious correlations that inevitably arise when searching through vast amounts of data? How do we avoid the trap of seeing patterns where none exist, while remaining open to patterns that challenge our preconceptions? The answer lies in developing new methodologies specifically designed for this kind of search. We need protocols for testing hypotheses about ancient technological signatures. We need standards for evaluating evidence that might point to non-human intelligence. We need frameworks for assigning confidence levels to anomalous findings. Most importantly, we need to acknowledge that this search requires a different mindset from normal science. Normal science seeks to confirm theories by finding expected results. The search for ancient intelligence requires us to take seriously the possibility that our most fundamental assumptions about Earth's history might be wrong. This doesn't mean abandoning scientific rigor. It means applying that rigor to questions we've never systematically investigated before. It means being willing to consider hypotheses that sound outlandish while subjecting them to the most stringent tests we can devise. The signals, if they exist, are almost certainly weak and ambiguous. They won't announce themselves with unmistakable clarity. They will hide in the noise disguised as random variation or natural phenomena. Finding them will require patience, sophistication, and a willingness to follow the data wherever it leads, even if it leads to conclusions that challenge everything we thought we knew about the history of life on Earth. But the potential reward justifies the effort, because if even one of those signals turns out to be real, if even one anomaly in the vast database of Earth's history points to intelligence older than our own, it would transform our understanding not just of our planet, but of our place in the universe. The noise is vast, and the signals are faint, but in that noise, encoded in ways we are only beginning to understand, the Earth may still be whispering the names of civilizations lost to time. We just need to learn how to listen. In the history of human understanding, there have been moments when everything changed, moments when a single observation or insight shifted our entire perspective on reality. The moment Galileo looked through his telescope and saw moons orbiting Jupiter. The moment Darwin realized that species could change over time. The moment Watson and Crick understood the structure of DNA. These threshold moments share certain characteristics. They often involve seeing something that was always there but never noticed. They require new tools or new ways of thinking that make previously invisible patterns suddenly visible, and they invariably reveal that reality is stranger and more complex than anyone had imagined. We may be approaching such a threshold moment in our understanding of Earth's deep history. The tools are converging: sophisticated geochemical analysis, massive computing power, machine learning algorithms capable of detecting subtle patterns in vast datasets. Our ability to read the record of the past is advancing rapidly, approaching levels of sensitivity that would have been unimaginable just decades ago. But tools alone don't create threshold moments. They also require the right questions, the right theoretical frameworks, and perhaps most importantly, the willingness to consider possibilities that seem to challenge everything we think we know. The question of ancient intelligence on Earth is precisely the kind of question that could trigger such a moment. It's a question that forces us to examine our assumptions about the uniqueness of human consciousness, the rarity of intelligence in the universe, and the completeness of our knowledge about Earth's past. Consider what a positive answer would mean. If we found genuine evidence of non-human intelligence in Earth's geological record, it would be more than just an interesting scientific discovery. It would fundamentally alter our understanding of what it means to be human, what it means to be intelligent, and what it means to live on this planet. Such a discovery would force us to confront the possibility that consciousness is not a rare cosmic accident, but a recurring theme in the evolution of complex systems. It would suggest that intelligence arises more readily than we thought, but also that it might be more transient than we hoped. The implications would ripple outward into every field of knowledge. Biology would have to grapple with the possibility that evolution can produce intelligence multiple times on the same planet. Geology would have to develop new frameworks for recognizing the signatures of biological intelligence in the rock record. Astronomy would have to reconsider its estimates of how common intelligent life might be in the universe. Philosophy and religion would face perhaps the greatest challenges. Much of human thought has been built on the assumption that we are unique, that consciousness as we experience it is unprecedented in the history of Earth. Discovering that we are part of a longer tradition of intelligent life would require fundamental revisions to our understanding of our place in the cosmos. But threshold moments can also involve negative results, findings that definitively rule out possibilities we thought were plausible. If we develop the ability to read Earth's geological record with perfect sensitivity, and if that reading reveals no trace of pre-human intelligence, that too would be a profound discovery. Such a result would confirm that consciousness is indeed rare, that the emergence of human intelligence represents something genuinely unprecedented in Earth's history. It would validate our sense of cosmic loneliness while simultaneously placing on us an even greater responsibility as possibly the only conscious witnesses to the universe's unfolding story. Either outcome would represent a threshold moment. Either would fundamentally change how we see ourselves and our world. The question is whether we are prepared for such a moment. Threshold moments in science often encounter resistance, not because the evidence is weak, but because the implications are too vast to easily accept. The idea that Earth might harbor secrets about the nature of consciousness challenges so many of our assumptions that even clear evidence might be difficult to acknowledge. This is why the approach matters as much as the result. The search for ancient intelligence must be conducted with the highest standards of scientific rigor, but also with genuine openness to unexpected outcomes. We must be prepared to find nothing, but also prepared to find something that changes everything. We must also be prepared for ambiguity. Threshold moments often begin not with definitive discoveries, but with puzzling anomalies that don't fit existing frameworks. The first evidence of ancient intelligence might not be unmistakable. It might be subtle, requiring years of investigation to confirm or refute. The patience to pursue such ambiguous evidence, to follow uncertain leads with scientific rigor, may be the most important quality we can bring to this search. Because threshold moments don't announce themselves, they emerge gradually from the accumulation of evidence, the development of new theoretical frameworks, and the willingness to take seriously possibilities that initially seem impossible. We are living at a unique moment in human history. Our tools for reading the past are more sophisticated than ever before. Our understanding of geology, chemistry, and biology provides a foundation for recognizing signatures of intelligence that previous generations would have missed entirely. If there are threshold moments waiting to be discovered in Earth's deep history, we may be the first generation capable of triggering them. The question is whether we have the wisdom to prepare for the consequences and the courage to follow the evidence wherever it leads. Because once we cross such a threshold, there is no going back. Once we know what Earth remembers about the history of consciousness on this planet, that knowledge becomes part of us forever, and it changes not just what we think about the past, but how we think about the future. The threshold is approaching. The only question is what we'll find when we cross it. Epilogue: The Eternal Echo. As we reach the end of our journey through deep time, we find ourselves in the same place we began, standing on the surface of an ancient world, looking down into depths that stretch far beyond our ability to fully comprehend. But something has changed in how we see that surface, how we understand those depths. The ground beneath our feet is no longer just rock and soil. It is a palimpsest, a document written and rewritten countless times, holding within its layers the memory of everything that has ever touched this planet. Every raindrop that has fallen, every creature that has lived and died, every event that has altered the chemistry of air or water or stone, all of it preserved in the patient archives of the Earth. And if consciousness itself is part of that story, if intelligence has arisen not once but many times in Earth's long history, then we are not alone in the way we once thought. We are part of a conversation that has been going on for billions of years, a dialogue between mind and matter, between awareness and the physical world. That conversation continues in us. Every time we look at a rock and wonder about its history, every time we split open an ancient layer and try to read what it remembers, we are adding our voice to that dialogue. We are conscious beings trying to understand consciousness itself, intelligence seeking intelligence across the vast expanses of time. The search for ancient civilizations is ultimately a search for ourselves. It is an attempt to understand what consciousness is, where it comes from, and where it might be going. It is a way of asking whether the awareness we experience, the sense of being present in the universe, is a brief anomaly or part of something larger and more enduring. We may never find definitive answers to these questions. The mathematics of preservation and discovery work against us. The sheer vastness of time and space makes certainty almost impossible, but the search itself changes us. It expands our sense of possibility, deepens our humility before the mystery of existence, and connects us to something larger than our individual lives. In the end, perhaps that is enough. Perhaps the value of the question lies not in finding an answer, but in allowing the question to live within us, to shape how we see the world and our place in it. Because when we look at the Earth as a repository of ancient memories, when we consider the possibility that consciousness has been exploring itself through countless forms across billions of years, we become part of that exploration. We become the latest chapter in the story of mind awakening to itself in the cosmos. And in that role, we have responsibilities. If we are indeed the first form of consciousness capable of remembering the deep past, then we are also the first capable of preserving it for the future. We are the first who might be able to break the cycle of forgetting that has characterized the history of intelligence on Earth. But preservation requires more than just maintaining records. It requires wisdom. It requires understanding not just what happened, but why it matters. It requires seeing ourselves not as the culmination of evolution, but as participants in something ongoing, something larger than any single species or civilization. The Earth will continue its patient work of remembering and forgetting long after we are gone. New layers will be laid down, new stories will be written in stone and chemistry, and perhaps millions of years from now, some other form of consciousness will look back through time and wonder about us the way we wonder about those who might have come before. They will find our layer in the rock, our chemical signature in the stone. They will see the evidence of our brief but intense transformation of the planet. And perhaps they will ask the same question we have been asking. Were we alone? Were we the first? Or were we part of something larger, some ongoing experiment in consciousness that has been unfolding since the world began? The answer will echo back through time, as it echoes forward into the future. We were not alone. We were never alone. We were part of the story, and the story never ends. The Earth remembers everything. The universe preserves every trace, and consciousness in all its myriad forms continues its ancient conversation with existence itself. Welcome to that conversation. Welcome to the eternal echo of awareness awakening to itself in the cosmos. Thank you for joining me on this journey through Simply About Earth. I hope it has changed the way you see the ground beneath your feet and the vast age of the world we inhabit. Let me know in the comments what you think. Are we the first, or are there others hidden in the silence of deep time? Share where you're watching from and what questions this has raised for you about our place in the cosmos. Until next time, keep wondering, keep questioning, and remember that every step you take is on a world that has been home to more stories than we will ever know. The Earth remembers everything. And now, so do you.